this is what YouTube does when you start a stream and it's like getting the buffer thing. Is apparently the length of the video is infinity and the timestamp is nan out of an hour. Because if you pre-schedule a stream, trying to control it. Pre-schedule a stream, it gets set to being an hour longer than the actual length of the stream, and then I guess the point I'm up to is infinity, and then because now it actually says the time. So this must be days, hours, minutes, seconds, because like infinity. I don't know, but I think it's funny that it gives me nan as the input. Anyway, I screenshot that because it was funny. So I had a nice relaxing weekend doing completely unrelated Bevy stuff. Trying to remember what happened. Go to my pull request so I get the name right. Turtle. Okay, yeah, it was Turtle. So Turtle apparently fixed the shader. It doesn't look very fixed to me, but I think that's because I've broken how we pass information to the shader, and it's not actually that the shader's broken. So these lines do look very, very bright. So I'm going to actually look at what they did to the shader. They split it up. So we do like get block and shading to normal, which is just basically split up so that in our fragment we just do these things. So this shading from normal, and then they texture sample of the block ID, and the block ID is extracted like that, and then we say position is resolve position. So it doesn't look like my code is what's broken, but like I don't quite get why it's so bright on the edges. That doesn't make sense to me. Potentially it's because I need to say, I reckon if I go here and I say if normal equals 0, 0 else. Can't overload this apparently, so I need to go like yeah, but giving them actual real type as well, just nice pick. 3 F. I assume works. No, okay. F3. Found boolean. You suck. Equals X, Y, Z. I thought I could compare this. Maybe I need to wrap it because I'm doing like a comparison like this. Apparently not. It does not want me to compare. If X equals 0 and Y equals 0 and Z equals 0, can we just like return like 0.5? If that darkens all the edges, it's basically saying that the normals are not correct. But if I return 0, it is reloading it. So I actually have no idea why the edges are crisp like that. That's a bit weird. So it's got to be how we're not how we're picking blocks, because how we're picking blocks doesn't matter. I don't think we need this XYZ, but anyway. Texture sample. We sample the block. Yeah, it doesn't actually make any sense to me whatsoever why it would be brighter. Like it's sampling around the edge when the block is there. Sampling the wrong block again. But it's not actually sampling the wrong block, because maybe it's sampling the block on the other side. So hence it's getting that like really bright green because it's sampling this other green block. Also, does it imply that dirt in the moment is currently green? It's a little bit weird. I probably just put the wrong colors in. Well, dirt should be brown according to the texture. Wonder if I'm sampling. Zoom in on our thing. Interesting. First off, that brown is atrocious. I'm gonna go to GIMP, edit up. I'm gonna open up my thing in the other window because it's quicker. YouTube, projects, voxelidal game, assets, color PNG. We zoom in on you and go. Apparently, there's an invisible one there. Okay, stretch. We're gonna go voxel, no, brown. Just the color brown. It's a nice brown there. Go back to GIMP. Bring GIMP over here. And then we just go here. We go color picker. I love that the color picker lets me pick anywhere. It doesn't like have to be restricted to my screen. We're just gonna pencil this one up like a proper brown. No, we're gonna file. We're gonna export. Now let's see what it does. Okay, next I think we want to make this 256. No. There's a trick you have to do to try and get it so that it actually samples the middle, because I think if you sample 255, when it divides 255 it gets 1. So you want to actually like always be slightly smaller than 1, slightly bigger than. But like you can see it's so close. But apparently dirt is returning the wrong number. Maybe it's because I'm passing the wrong number when I actually do the dirt. I don't think so, because otherwise grass would be wrong. Map. We're gonna have blocks, and we go. Grass returns 1, dirt returns 2. When we say ID, grass is 1, dirt is 2. So this is returning the color 2. When it returns the color 2, it's getting the wrong block. So I said, please sample block ID +1. But now it's like a grey and there's snow down there for some reason. Then the stone. See, so that is what's going on, and then like that's what that trim is it's sampling the next color over, so the grass becomes brown. So it is just I think that's easy to fix actually. We say like plus 1 divided by 250 at 512. 512. So effectively half a block. There we go. Need to offset everything by half a block so that it actually samples the middle. So at the moment what's happening is got a GIMP. When we give it 0, we're sampling here. When we give it 1, we're sampling here. When we give it 2, we're sampling here, which means that rounding errors give us it's like 1 color over. So that really bright theme is probably where it's sampling air and actually putting block, because we only discard it if air is actually sampled. Okay, that's cool. Now I'm also curious what my frame rate is, because ironically I wasn't compiling everything in release mode, and we've also like greatly reduced the number of blocks per chunk, which LOD doesn't seem to be working properly, but it's actually kind of cool that it almost does it in that it's so good. So it's actually sampling the full voxel thing. It's just only rendering the blocks like every 8th because the mesh is missing, which I think is the LOD not being done in the shader. Like the shader is not actually sampling the LOD properly. But that's kind of cool because it actually looks kind of right. Anyway, we're gonna go to our texture. No, we're gonna go to our world, and we're gonna, I guess, because we had to reduce the number of chunks, we have to go from like, I want to say like -2 to 10, and then we hope like hell that this doesn't kill our frame rate. Yeah, alright, that's fun, because the LED actually looks kind of cool at a distance. I just wanted to see if the mountains worked all the way up, and let's see what our frame rate is after we'd like effectively like did like 3 times as many chunks, and we're back down to 20. So we must only just be getting to 60. So strangely, the LED stuff is causing issues because it's actually sampling at full resolution for things. It does decrease because it goes further away, but it like ignores a lot of the stuff because there's just not blocks there to do it. It does look kind of cool though. And it's also getting issues at the LED stuff where it's still sampling like 1 block over. As you can see, it's got a little trim around it. So the LED stuff is kind of weird. But again, the player shouldn't actually be able to get out of this chunk. So technically it needs to look okay from like this distance. Obviously it doesn't, but it's actually got no LED stuff running at all at the moment. But what I was going to do today is work on actually giving the data to the shader properly, because at the moment, I believe we have a vector that is a 16 by 16 by 16 vector. So we can actually turn that into a proper buffer and pass it in as a buffer instead of an array. And that means that Bevy won't copy paste the memory every single time, because I'm suspecting if I go to task manager, go to my GPU usage, that the bottleneck is going to be apparently nothing, which is confusing. It's going to be dedicated memory, I'm sure. Another thing to probably do is change how chunks work. Actually, that might be pretty clever. That also is going to need like a custom. Yeah, that will need a custom implementation. God damn it! I was going to make this an enum so that like empty and filled with a single block could be enum variants, and therefore you could use like a single byte to represent them. All right, anyway, we should, because I noticed the other day when I was fucking around with it on stream that Bevy said something about if you want to use a storage, it has to be a pointer to the shader thing. So that's actually kind of cool, because that means what we can do is we can replace this with a proper chunk thing, maybe. I don't know how to do this. Also, apparently my stream is buffering, which is annoying. I think I want to do a separate chunk, pass that in, and make sure I don't break anything. But I guess that's what Git's about, is we can say fuck it and like do the full conversion. So we want to go Bevy rendering shader, no, render asset graph, render resource, no, they're called shader buffer, shader storage buffer. Right, which has a data optional vec2 buffer descriptor and a usage of the storage buffer that is prepared as a not as GPU, and then the shader, if memory serves, would then take in. So we could say that this is a storage. Oh, look, a storage texture. Is that a thing? Wait a second. Option reference to. Wait a second. Did I just like find what we were looking for? A storage texture? Because if a storage texture is what I think it is, that means that a storage texture is like what I was trying to do the other day, where I was saying, hey, this is actually a data of the texture 3D U. No, how do I do this? Var. It's not a uniform, it's just a var data. You don't like this because access type image dim 3D arrange false sampler. So because this is how we get the data up. Right. Which is to say we need to say that data is equal to texture sample and then it's data. I think I need a second sampler though. but we should probably grab the sampler. Brain, slow the fuck down. Duplicate it, then bring it down. Get rid of this one. This is 6. Right. So you're saying that this is data sampler and sampler. Then we come down here and we say, hey, you're a texture sample, data sample. Can we say like a, so this is vec3? Can we parse in so we're going to pass in pos z, pos, oh no, it's pos x, pos y. We're just passing pos, I guess. Like this. Like this. What are you complaining about? Okay, so f vec 3 f 32 something like this. No, okay. Dot x f 32 y post dot z chunk size xyz. All right, okay. You can definitely do dynamic linking. I don't know. I haven't set up dynamic linking. Once you compile for the first time, Bevy tends to be much quicker to compile, but like you're still talking like 30 seconds for it to do the final linking stage. So I don't know. You have to look into it. There are things out there that do it. X. So I'm trying to think what I was doing here. Yeah, you could definitely do. So you're saying if I replace this with pos.x and say yeah. Oh no, pos with x. Pos. Okay. Lovely. It says index 3 is out of bounds. I don't know where that is. Failed to process shader, error, index 3 is out of bounds. Trying to index something with something. Not clever apparently. X, Y, Z, W. Wait, does it not have a W now? Okay. Yeah, but I don't think I want to. We're passing in a position. I think what's changed is we're no longer, actually this case probably doesn't actually happen now, and that we just say oh yeah right XYZW, yeah, gotcha, XYZW, because we have the W. It's going, we don't need the W because but like yeah, the W is the alpha channel. It's going because we're using a texture now, but it's still for floats. Okay, so it's still not going to work because we haven't actually updated Bevy to give us the right information, which means that nothing's going to render, which apparently makes our frame rate really good. So we have to modify everything and go, hey, so this block thing, chunk. I think this we can actually say that we can take chunk data back to being full size chunk data, except we're going to go back to being blocks. Like so. And again, we're just going to get I, and we're just going to set I to block ID. And then I is just going to get index, and then we can get rid of this as well. We have to go back to here. This is just going to become a vector. So we're going to go here, and it's going to say, you're actually back to being an array of blocks. No, just back to blocks. You're no longer a shader type. So what I'm going to do is I'm going to swap back to seeing if this works as a UI image instead now. because I've told it it's a sampling shader. Self blocks, use blocks, and blocks I from block ID. I think you can just return block I now. You can just equal block now, which not only makes the type smaller. Okay, we can come down here and we can go, hey, chunk. I guess spawn, chunk data empty. You want to handle it on image. Okay, right. So we can say chunk data to image. And then the image is this, and then RGB uint. So RGBA 32 int, because I think I can do something like 8 int, and then that means that like it tells the sampler that they're U8s or and it therefore like actually like compresses the data for me, and I don't have to keep like rearranging in the shader because the shader will decompress them into U32s. Asset server dot add. I actually think it might need to go back to none option, not material, because we actually don't know what have the data, so it's going to be like some option. Like this. Then we go here and we say none. And then somewhere down here we go, hey, when we do this and this and this, when you stick this in here, we're going to say some chunk data. So then we say chunk is apparently, oh yeah, you are a handle to the chunk data. So we say you add this. We need to say like let I equal like data dot to image, and then I, and then I'm hoping that this works, and then insert chunk. Effectively, we're redoing a bunch of shit that we're doing earlier, and then you're also back to just being none. Thank you. Well, actually no, your assets asset server add image. Right, let me see if this works, or is Bevy going to yell at us that we're giving it an image that's a U size now? Because I'm sure it's no, Bevy still doesn't like that. Okay, so wait, it wanted RGBA 8 unorm, but was given the format RGBA 32 uint. Wait, that YORM. What the fuck is a YORM though? So it still wants RGBA, but it wants a YORM, which is interesting. Because actually, ironically, that might be exactly what I want. In that now, instead of sending a whole 32 bytes of data at a time for each block, we can just use the single byte. So field data is never read. Okay. Yeah, unsigned norm doesn't make any sense. I think what it's saying is it's unsigned and normalized. Meaning you want 0 to 255 to represent 0 to 1 normalized. Like you can't pass in 1000 unless you know in the shader how to convert 1000 back. An 8-bit normalized unsigned float, but it's not a no. Because in Rust, all U sizes are integers. It'd be I if it was signed, I think. Or is norm different to an int because this is a 32 U int, whereas this is normalized, so maybe it is a float. The fuck? That might be even more confusing, to be honest. Because if it's a U8 float, what the fuck does it actually store? I mean, I think I can overwrite that, by the way. Just slightly confusing. We have to go to here, and then say, oh, there's also the whole sampler. Sampler is 6. Oh, apparently the sampler can't be attached to a storage texture. It must have its own sampler. The fuck? So it can be storage texture, sampler, bind group data. Huh. Storage, bind list, and data. So there are things we could be doing to make this even better, but I don't understand shaders enough to fuck with this shit. So you're saying that it can't be a bind group because I did that? Yep. Right. What can you take in? I'm actually amazed that it lets me go here. Okay, so somehow as bind group attribute, so storage texture. So we pass this in here and we pass this in here. So it's this, and then we have to go somewhere that storage texture is, so binding type, when is binding type used? Okay, binding state free, match binding type uniform, everything else occupied binding type. Occupied, okay, where's the next use? Get storage binding attribute. Nested meta items. Okay, not a valid name attributes. Okay, so we have dimension, image format, and access. Okay. So, dimension 3D. You gonna complain? No. Okay. Format equals RGBA int. No, image format. Image format. Expected identifier. No, so it's gonna be like image texture format. There is a TX T Yuri FO FORAM. No valid name texture format. Yeah, we don't import. Okay. Also I remember to jump into Discord stuff so that people can chat them up. Okay, what was I doing? So I was going to say use Bevy rendering image. No, Bevy render resource texture. Texture, very, nope. Format. Features. No. What the fuck is this? Okay. What the fuck? What type is this supposed to be? You can pass in U8s, but on the GPU side, it gets automatically converted to a float, so you can get the full speed of the GPU, but less mem. Yeah. So as I figured that's what it was when it said it was a U8 normalizes. It's basically saying you have to make sure that your value 0 is 0 and 255 is 1. Was my first guess at what a U8 normalized would be. I'm trying to work out how to fucking pass an image format in, because it's doing my head in it. It wants some kind of get bind fucking texture. Okay, image format, storage texture attribute image format, embed token stream, metaname if metaname path image format. What are you returning? Match meta. Okay, storage texture attribute image format. This is it's token stream again. The worst, because all that means is we have to go back up to like 4. Okay, we're storage with text image format. Where the fuck is image format used? So type there. So it's render path, render resource, texture format, image format. Okay, so I just need to put the actual name in. So it's render resource, texture format. This will just let me see what they're called. Right, which I believe is just what I'm using. Yep, okay. So CPU side, you pass in 0 to 55, but the shader sampler and I think it's actually, I don't know, because you're saying none of the other shaders have this, but I think because of how the sampler works, it's actually loaded onto the GPU as 0 to 255, but the sampler passes it to the fragment shader as a float 0 to 1, meaning that like all that stride issue goes away of being like, oh, they have to be strides of 16. It's like the sampler can sample below that, like the sampler will grab 16 but only read it as 8, so you can actually pack things much tighter. I think. I'm not entirely sure, I haven't really fucked around with it, but I think you can do that, which means it actually takes up less memory, which is kind of like a cool way of doing it. Storage texture. Okay, still doesn't like it. I'm just gonna like peek down here and going, what was the third attribute that we can get? Access. Visibility? Access. Alright. So we go back up to 4. And we go, you poked this and access. Access. Storage texture access. So render path, render resource, storage texture access. Okay. Use Bevy render resources, storage texture. Oh, texture access. What the fuck types do you have? So you can be write only, read write, and atomic. Ooh, fancy. Alright, we don't care. I don't know what it defaults to, but we don't care. Yeah, well, it's not even like just low bandwidth. It's like it's low memory devices as well, because like if it actually does pack, like if it does actually load it on the GPU and the sampler is what unwraps it into a float, what it's saying is that like it can use a fixed bit of the pipeline to result in having a quarter the memory use, because you're only putting 1 U8 per float that then is converted, so the GPU doesn't have to have dedicated memory for treating floats and integers, and the sampler is done with a fixed bit of hardware, so it can actually sample quicker, which means that basically I'm quadrupling the memory usage as long as I can fit my data into 0 to 1, I guess into 255 steps, which also for us would be really good, because one of our big issues is the shader sort of rounding values after a certain distance, but ints don't have that issue because we're saying that each 0 to 1 is 255. And so we make the steps smaller, but don't actually fix anything. All right, so it's saying handling the error fatal. It said in-device create custom material, usage, label, storage binding, texture usage, storage binding. Usage flags, texture binding, texture view. I might have to look up how to use, because I think that's saying that because we called this a, also we got, because we have this, oh, we definitely need something. Okay, maybe I should just do some Googling and be like, wait, something load? Texture load? Wait, you what? I look that up. WGSL texture load. Did the AI just save me a bunch of time because it suggested maybe change texture sample to texture load, and it's actually correct? The fuck? Texture load, please. Nope, that's the wrong button. Go back. Texture load. Read a single texel from the texture without sampling or filtering. You what? Okay. Okay, it still doesn't like it because apparently I'm doing something wrong, but it seems to be saying, well, it's sort of a, maybe I can't sample it if it's not there. If device, in device, create bind group, label custom material. Yep. Use flag, texture usage, use copy source, copy destination, texture binding of texture view with no label. Label did not contain required usage flag, storage binding. Okay. So this does feel like we need to go Google some stuff. I've got way too many tabs open still. Let's pull this one over. I'm gonna go Bevy storage texture. Usage. You must define texture with specific usage as texture binding, or for reading a storage binding, or storage binding for read or access in shader access into usage. Oh, it's a texture storage 2D format read write to allow. Wait a second. So you're telling me that I have to actually go into the shader and say that this is a texture is a storage texture 2D. What did it fucking call it? It calls it a texture storage 2D. So texture storage 3D. Unexpected token. And then you'll read. Nope, it did not like that one. That one crashed even quicker. Why? Why? Well, it doesn't seem to actually have a problem with this. This seems apparently correct. Alright, go back to the Google thing and say, what did you say? Format. What the fuck is format though? Yeah. So I mean, here's the storage buffer of our storage. Maybe I need to call it a var storage texture. Ready? Var storage read. Maybe that will work. Nope. Texture 3D, maybe like this. No. The fuck? Go back to chat so I don't miss if you found the solution. Okay. I didn't think it would let me do that because it just feels odd that it's like I can specify actual formats like that, but maybe. Because I guess you don't give it a sampler. So if you don't give it a sampler, because it literally says that it like my texture. What do they call it? Data set. My texture. Wait. Texture load. Why is F32s now? R30. RGB so you went the actual type. Oh, so it is actually reading the fucking. Yeah, no, I'm surprised that like it takes in these like I guess these are standards, aren't they? I keep feeling that like in my head that they're Bevy types. Also, I'm passing the data sampler, but like, do I actually need to pass in the data sampler? Does the texture load? Texture load takes in the texture coordinate and then the level, so it doesn't actually need the data sampler, and that's probably going to cause issues. Also, do I need to just do WGS? It should just be the same type, yeah. Still doesn't like it. Is it Bevy doing this? Oh, this is the annoying thing. I don't know if I Doctronic sample the texture. Does it work now? No. If I stop having it all together, does it work? No. What if I, because we don't have a binding 6, stop telling it to have a binding 6? No. So that makes me feel like it's Bevy that's doing that. No, but it says handling WGPU errors is fatal. So in device create binding label, it's saying that I can't do that because I'm saying that the are you being annoying and it's going to boil down to something stupid like I have to go to here and I need to say that your access is storage texture access read only. But really annoyed if I have to actually specify the access because it doesn't work otherwise. No, it's not that. So, label does not contain required flag storage binding of texture view. Why? What is going on? If I get rid of this bit, no, doesn't like that either. Oh, apparently controls even fucking work. Hey, norm. Because it was an RGB8 norm was new norm was the one that it came up with. Okay, so now it's yelling at me saying that the types are wrong, which means it is definitely a Bevy issue. In that, like, it doesn't like that this is happening when it's happening. Maybe we should pass in U8 norms and see if we get the same crash there. So it would be under chunk data when we generate our image to image. We pass in this and we say that you are RGB A8 U norm. I don't know how it's going to actually store that data, but presumably correctly. It doesn't like that. Okay, so it's got something to do, potentially not even with the handle. Like, if I go back to our voxel thing and said, hey, just like don't do this. It's going to complain about other places where I'm using that. Don't set the data. Don't set the data. Get rid of data entirely. You have issues because that's again that's data. See, if it works without the thing, it's gonna be really annoying. Okay. Anyone change? You have to change the format in the shader from to be A. Did you change it back? Well, that's what's confusing me is that I don't think it reads the shader, but I didn't change it back. I just removed it entirely from the shader. That's what's throwing me. So it's, you're saying something should change the shader side from. Oh yeah, okay. So you're saying make this read, and then it's saying no, but it's what it's complaining about, because I'm pretty sure the shader side doesn't have a problem as long as it has an error in the shader, but like it doesn't actually have a problem. It's Bevy is trying to pass in data, and Bevy's saying, hey, you're trying to turn a thing that's not declared as a buffer into a buffer. And I'm throwing me because it doesn't make sense why it would be trying to do that. All right, so we have to turn this back on. We have to go, hey, you are a storage buffer of this type, which 32 UN. Right, access read only. I have to fix all the other places where I removed it. So you just get access to your image, which is fine. And then down here, you get access to none. It could be this none as well, because it wouldn't surprise me if Bevy was having an issue that you can't not have a texture loaded, like a storage texture. Ooh, it crashed like hard this time. That's good, because a harder crash means that like, ooh, okay. Storage type, expected format you went, but was given the format. Oh, okay, okay. But as I say, hard crash is so much better because a hard crash implies that it like it gives a much better error than a soft crash where it's not backtracing, it's just soft crashing. There's the other issues. I could also be like, because I'm not in release mode. Oh, okay, we're gonna have a hard crash, which is good. Did I not save? To image is RGB. But was given the following format. Did it just like not? Apparently just didn't recompile. Mustn't have saved. Fucking Rust Analyzer and its bullshit again. Okay, so it's still hard crashing. It's still getting given the wrong type, which is kind of funny. Why are you getting given the wrong type? Like, the shader has got the right type. Okay, storage texture binding 5, expected format. Is that because it's like just the default format? Like, what do you mean? Yeah, I get why they're incompatible. I'm just saying I did change it. Like, this is where I was telling you what the format is. So this is saying that the texture I'm handing to the shader expects it to be this type, but the image I gave it is this type, but it's not. So I'm very confused about where it's getting an image that's not the right type. And I'm wondering if it's because I'm doing something like here that's wrong. Like when I load the chunk, I pass in. Okay. Brain. I can pass in none. Wherever it was that I do the here. So because I can pass in none, I feel like it's fucking turning none to the wrong type. Because this is RGBUN, which is this bit here. This is saying it expected this format, but it got this format. But where the hell is it getting that format from? Because I'm not giving it any fucking images. Right. What if we just like never give it an image? So I think it's not chunk gen. It must be here. Somewhere over the rainbow. Update. Is it here? Well, that would probably help. It sure doesn't make any sense to me because I don't quite understand how it's fucking... Okay. Now we're back to here. So apparently giving it a texture of none also causes it to crash because I guess none is the wrong type. So now that I'm actually giving it a texture again, wait a second, it already had an image. Why am I doing that? Just, I don't need to double image it. Okay. So, what this error is saying is that I have set these flags, but it needs to have the texture usage storage buffer, which might be me in that when we gen image here, we say render asset usage all. So, no, not there. I think it could be that like we're not setting texture buffer because we're saying skirt texture binding. And it's saying actually it should be a storage binding. So was that, so down here somewhere they got a custom material, custom handle, custom material, shaded storage buffer. So yeah, they're using a storage buffer, which is just fucking annoying because it's a storage 0 read only. Well, isn't it? So it's not an image format thing anymore. Like I say, all I was not giving it an image, and it was defaulting. If the handle is none, it tries to give it, I guess, an empty, like a zero-sized image that was the wrong format, because that seems like a Bevy bug. Is that if you don't give it a texture, like if you don't give it an image handle, it just makes a dummy handle that I guess will always return black or something. I don't know what color it'll actually return. But the idea being that it was giving it a dummy handle, but that dummy handle was the wrong type. So it was having a fit at the fact that we were trying to use a dummy handle. So as soon as I actually load the image, which is what's happening down here. Here? No, it's in here. So better add this line comment out. This line was saying the image. So the image itself knows what format type it is, so it's not the assets of anything. But what's happening now is it's saying that we're calling it a texture binding, but it's saying that it should be a storage binding. And my question is that happening because Bevy's trying to validate between the shader? Like, if we do this, does it work now because now it's a texture? No, apparently not. So it's basically saying that it needs to be a storage binding. So with blank label did not contain required usage flags, texture usage, storage. It's saying I can copy the texture from the CPU to the GPU, I can copy from the GPU to the CPU, and I can bind it as a texture, but I can't use it as a storage. Which is very confusing to me. And I think fucking around in the shade is not going to change anything because the shade is not actually where it's crashing. It's crashing before it gets to the shader because Bevy's basically saying, I don't want to give it the right types. Which I guess technically means that it's probably this that's wrong. Is that I'm saying read only. Maybe if I got rid of this, maybe this is entirely a issue with the fact that I'm giving it read only and actually wants read and storage or read and write, something like that. Maybe because I'm calling it a storage buffer, but I'm not letting it be storage, it's just a sample list. Nope, it's still that, okay. Possibly. It could be because I'm calling it a storage texture, so the options are read write. Like, can we F12 here? Okay. So atomic. Texture can be both red and red in the shader via atomics, but and must be annotated with read write in the WGSL. Right? Okay, read only. Okay, so read write. The texture can both be read and written still in the shader and must be annotated with read write in the shader. Read only. The texture can only be read in the shader and it must be annotated with read or read only. And then must be answered write and write only. The other question is there a... See, but it's complaining, it's not complaining that I don't have a read, it's saying that I have a texture and I'm trying to use it as a storage. That's why I was just trying to, like, what if I change this to a texture 3D? Because then it's a texture, not a storage. Read. Oop. Right. My other thing is maybe it should be something like storage. No, and so what's annoying about this is that Bevy doesn't seem to have any examples, because so we've got read only here, and then you come here and you get storage buffer, and then say binding 0 var storage read. Yeah, maybe. Yeah, I don't know. What's throwing me is it says that it's trying to textures. Is it says quite like specifically that it has a texture. It is a texture, and it's trying to make it. So it makes me think that like the actual type I'm using in the shader might be wrong for Bevy's shaded buffer or whatever. Current shade. Okay, this has the ability to annotate struct fields with a storage texture annotation instead of adding specific options passed for all images formats. It simply accepts a token stream and defer checking to see if the option is valid to the compiler. This still results in useful and friendly errors and is free to maintain and always. Okay, so change log annotations now accept for fields of image. This struct is the buffer to game storage to date. Image files, right? Did they by any chance give us any fucking examples? No. Oh no, they did. Okay, so this was... So to get to this example shader. So we have to go to example shaders, compute shader game of life. Right. Excuse me, GitHub, but can you please free me? I think I spammed that button a little bit too much. Bevy. Bevy. Okay, so we're gonna go examples, shaders, compute shader game of life. Now, the question is, yeah, handle the texture, prepare bind group. Where is the actual... Okay, the shader is game of life WGSL. Okay, so let's just have a quick squiz at setup. So they generate the images. Oh look, image, texture used, its usage, texture binding, texture usage, storage binding. You suck. You suck. Okay. I'm just gonna keep telling you how much it fucking sucks. What do you fucking mean I have to... Start. Usage. Asset usage. I don't think it's render asset usage. It's a different thing. It's like a texture descriptor. Texture descriptor dot usage or equals fucking storage binding. Right, so basically the image needs to be flagged as being a storage binding. Hey, and now it's back to fucking telling me that the type is wrong. Well, that's better than nothing. Aha! I know the type is wrong, because the fucking nuns are still wrong. I hate you. So what's happening here is I'm pretty sure because the fucking hub dummy image. All right, then we have to go. No, so what's happening is I'm pretty sure Bevy, like nobody's fucking done this, what we're doing before. Like the only person that's doing it is the person that literally implemented it. So what's happening is if we go to bind group, our shader, because that was the thing is before we were having this issue, then we gave it that other one and it decided the other issue was more pressing, and now we've gone back to this. What's happening, I suspect, is that the default image for when this is set to none is this. So what we need to do is this, right? And say you can't not have an image set. And then we can track down the locations and we're going to go, hey, you are this, because you're always going to have an image. This is my dummy cube. It literally generates a random chunk, random generated chunk that I can move around. And then we go to somewhere. Where do I, like here, right? So we're passing in data sum, add image, which means we don't care. We can just say data image, and then we track down the other location that's having an error. One of these locations is passed in none, and that's what I'm saying. None is not acceptable. We can't pass in none here. So what we need to do is go, it's you. We go to you, and we say, hey, dummy image, which is just, you know, a handle to an image, right? Which fixes that, which means we go down here. Somewhere we have, where we have none, we're going to say self.dummyImage.one, right? So we're going to use the same image everywhere because it actually is quite a large image, so we don't really want to be having a dummy image everywhere. And then we go here and we say asset server. So dummy image is asset server add, not image default, please, is chunk. Chunk data dummy image. Right, so basically when we generate our mesh builder, we give it a dummy image, which is just a chunk that's basically entirely void, so that we never have a situation where we're passing in Bevy's default none image. Hey, and now it doesn't crash because we're no longer giving it a none image, because the none image, I believe Bevy, actually Bevy might have an option for this in that there's something like fallback image. A render app resource that contains the default fallback image, which can be used in situations where an image is not explicitly defined. This crashes my application because the fallback image is the RGBA thingamabob, not so this is going to be reading. Yeah, effectively the fallback image is the wrong type for my specific use case. So it's trying to load the fallback image because I said none, and that's not allowed apparently. Also, I have no idea if the stream's working properly because my preview's broken. Anyway, it's still generating lots of chunks, but did it throw an error? It did. Okay. What's the error now? Unknown identifier, block data. Okay, so we're back to it actually being only shader issues. So you're saying that you can't do this because we stopped sampling the texture. So now we load the texture, and now we don't have to convert these back to U8s. We can just pass them in. To a certain extent, I feel like the default case, because we're no longer doing it as a chain of if statements and we're here, we should probably say that the get block should... I wish we could return something else. I guess technically we can return 0 because we're getting the block ID and then we use that block ID to sample. So basically the idea is if we hit the default, we return 0. Actually, can we return 255? Return 255. And then I want to go into GIMP and go here and go all the way to the end here. All the way to the end, please. We're going to go magenta. File, export as, export, replace, export. So, magenta. The idea being that if we do hit the default case, we will return an error color. I don't know what your problem is. FN bool U8. What? Yeah, I don't know. So get block. Okay, so something get block is invalid. Image coordinate did not match. Oh yeah, because we converted it to an F. So, excuse me. Pause. Pause. Oh, it really didn't like that one. I tried to sample the texture, like, I guess out of bounds, maybe? It still doesn't really like that one. What the fuck's going on? Okay. So, shader, error matching, shader fragment, shader requirement against the pipeline, shader global reference, binding 5 is not available in the pipeline layout. Visibility flags did not include the shader stage. What? So, fuck you. Fuck you. Fuck you. I hate this so much. That is almost certainly going to be here, where we generate our image, wherever the fuck that is, to image. And probably the dummy image as well. We need to say, fuck you. Bevy render resource texture usage fragment. No. Alright, so it's not usage. It must be visibility. Okay, fuck you. Alright. Image dot texture descriptor dot texture descriptor image dot visibility. How do I do it? Is it you like tell it? Was there something that like maybe the macro had? There was like a visibility one. You storage texture. You piece of shit. In here. Storage texture. That was like number 4. Visibility. Where the fuck did you get the visibility from? So in here, we say visibility. Okay. Oh, why? Why? Why is it different? Fuck you. The worst. Why are you different? I will forever be angry at you. Like that, if I remember. No. Okay. Not valid visibility. Oh, because it's lowercase f. It's lowercase frag. Fuck you. Yeah, so what I'm doing is basically if the block fails to get got, so like basically if we hit the default, if we hit the error case down here, I'm saying like return a magenta block, saying like I want to know if I hit the error case and not just return the block that's in the wrong place. Like returning data block data.x would result in us returning a block that was effectively in the 4th position rather than what we're actually doing. I also feel like we don't need to be doing this because each block currently yeah, okay, wait a second. I just realized that we could just say I think we just return block data.x because I mean the idea is it should never hit that case, but like if it does hit that case, I want it to be purple. Now, we are apparently encoding this data in the wrong way. But I think what's happening now, outside of this chunk stuff looking quite small, which is a bit weird, is technically every block now gets its own pixel again, which means that each block now gets way more data than it fucking needs. Each block is back up to 64 bytesy thingsies of data. But we can go back down to U8 representation later. I'm just curious. Because the idea being that like now we're actually back down to value. Why is every block gray? Can I just return can I comment this out and say return 1? That should make every block grass, yes? Yes, every block is now grass. Forever and always. And now every block is void. For always, okay? So if I return block.x, every block is apparently gray, which makes me feel like it's returning effectively noise and not the value we actually want. I feel like we can't be masking off whatever it is. Oh. This feels more like we're passing in the wrong data. So we want to be like saying like X, and then I want to be going like, when I pass in a chunk, when I say like to image, chunk is turning into this. And then we say that the data is all zeros, which is fine because they should be invisible otherwise, which means it is getting something. And then we pass in the data and then we assign and we set each block. And I think this is probably what's causing our issue, is that we're setting the blocks to these colors. And the dirt's color is brown. And then we're setting the color. Yeah, okay. So we don't actually want to be doing that. We kind of just need to go in here and say, hey. So you're also setting color at dimension. Set color at internal. And then you get each format, and then you basically effectively say, hey, you encode each one into a byte. And then you're a... No, so what I did is I stopped passing in a vector and I started passing in an image, and then we're sampling each pixel in the image as one block, which is, yeah, I guess technically I removed the packing on the Rust side because now we're passing in a texture, and because it doesn't need to reload the texture every time, that's technically faster than passing in a quarter amount of data, because it'll leave the texture on the GPU, whereas when it's a uniform, it needs to load it every single like time the shader changes. So, wow, look at that. That's so dumb. Why does it do this? This is so terrible of a way of doing this. Anyway, I now happen to know that if we pass in that, we can just pass in all 16 bytes, which means that we can just stop doing that. Like, how does it encode the position? That's the only thing we need to do in the image. We just have to say, hey, when we set your fucking coordinate, you piece of shit, set coordinate internal, you do the format, and then you extract this, and then you say bytes. How do you get bytes? Pixel, is this public? Huh. All right, the answer's fuck you. I'm just gonna copy this. And then we go here and we say, hey, let some bytes is equal to image. Get this, right? This, and then we say, hey, return error add sure. Can we just hit panic because I can't be fucked? Actually, no, just error. Failed to get pixel out of bounds. Continue. There we go. Coordinates is gotta pass in something. To uvec 3 new, which is then x as u32, y as u32, z as u32. Right. I need to restart my Visual Studio Code because it is getting out of control slow. Just so fucking annoying. Code. Okay. So now we have access to the bytes. And then with access to the bytes, we can just say, if bytes.len equals is it 32 because it's 4 times 4. It's 16, isn't it? 16. That's 4 times 4. 4 times 4, 16. Yep. Okay. So equals 16. We're gonna do something else. Panic. Right. That's just so that when I accidentally fuck this up later by changing something, I don't go, oh, what the fuck's it all not working again? Because I'm explicitly just testing something right now. I'm gonna say byte. I want to set 4 because it's the lowest byte. So actually it'll be 3. Equals somewhere we have the block. Where the fuck do we get the color self.get block? Okay, and then we say sure. So we're gonna say don't let the color. We're gonna say let color equals this. And this block. I'm just gonna rename you to block. We're gonna say block. Wait a second. Yeah, we can say u dot 4 equals block.id 2 little endian bytes. Dot, is it fill? No. Copy from slice. There we go. So this should then copy the block position into the red channel of the red channel of the pixel, and then that should mean that we can actually like see it again. Hey! Dun 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 dun. Now something's gone a bit weird here because, like, as you can quite clearly see, we can see a lot of dirt, but that might just be because our mountain's quite steep. This doesn't math out properly. Something's wrong with this mountain. It looks very choppy, if you know what I mean. Like, something feels wrong about the shape of this mountain. Something feels off. Anyway, it isn't even mathematically it's correct. Anyway, so all we can do now is we can just say, actually, you're a 8. And then we don't have to do this. We can just say byte 0 equals block dot as u8. Right? Does that work? No. Okay. Fuck you. Dot type. I'm gonna say block type. I can do that, and then block type's gonna return a u8 because again, like it's about like trying to make block here pack data in a nice efficient way. So we're gonna say, look at somewhere, get back to block. Fuck you. And then block type this, and then so we're gonna actually say that you take in ID, and then you're going to reference to ID, and then you're going to return 128 plus ID shifted 1. I think it's reference. No, there's a way to fucking make this not do what it's doing right now. Just that it's getting us a fuck you. Sure, do that. Right, let's do that. Well, I don't know what's going on because it does feel like it's doing the too wide thing, but the thing is I haven't actually changed any of the code, and we're still at 0, so it actually should be just the level 1 LOD. So what could possibly be happening is we've gone back to having a rounding error that because we're sampling the bottom texel in the texture, we're like ending up with like 2 textures sampling it. This is exactly why I put that error logging in there, as I was going like, I have changed something. It's probably going to crash in a whole bunch of different places too, because I haven't actually told everything that's been changed. Oh, where was that chunk here? So when we get image, so first up we have to change you, right? So you're the image. You're now like a 16th size. You should be 4 because now you're a 4 pixel, and then we have to go where the fuck else we touch the fucking texture. So it's just here. We're gonna say you're a RGBA 8, and then I think also you're also an RGB 8, like that. And then I mean that should be all the places that we care. When we generate the image, when we pass the image to the shader, and inside the shader itself. Ew. Yeah, I think it's just like it's weird. You're right. It's like all the fucking. They're all wide. They are wide, boys. Oh, I bet you we're stepping by 4 in the shader. So now we have the texture. So somewhere we're dividing by 4 when we're not supposed to be dividing by 4 anymore, because we're no longer putting 4. Our index shouldn't matter because we never fucking sample the index. Where's position coming from? Floor. Do we actually use the index? I don't think we use the index. That would make the most sense to be where. So something is going wrong here. Maybe it's when I'm actually generating the chunks or something. So you're dummy generate set block. The set block, get the block index. There we go. Found it. No, we're making a voxel rendering engine. It's technically going to be way smaller than Minecraft. The idea is that we're not rendering, like we're not generating a mesh to store our voxels. We're generating a mesh that basically is every possible voxel location, and then we're discarding any pixels that don't actually have a voxel in them. So instead of having to regenerate the mesh every time you change the world, you actually just change the world, and the GPU renders the world correctly. There's no like, I need to make the mesh now for the world to render. It just sends the corrected data to the GPU. It updates the texture, and then the texture is actually what tells it what to render, and not like a mesh. We definitely still have a rounding error somewhere that we're not like recentering and sampling the center of a block anymore. Anyway. Cool. So I'm just gonna like correct this so that we don't store it and then divide by 4 and go, okay. So you inline always, I think you also inline always. Empty set block also should inline always. Don't allow inline, please. The reason for always inlining is because this is literally just going here, and then this is equaling to that. There's like 2 lines of code that this function call should never happen. It should always just inline it, because it literally is never going to be better not to. And I think it makes the compile time faster to say always, because it means that the compiler doesn't bother checking, it just does it. Okay, so the question is, with our new and improved chunk reduction like that, can I go back to really big chunks again? Because in theory, not only do we have a quarter of the amount of data being stored in our thing, so we can have 4 times as many chunks before we overflow our memory. Like, let's go look at how much memory. We use a lot of CPU. We're using very little memory compared to what we used to use. It is also still taking a very long time to generate all these extra chunks, but that's because we have to generate like 1 million times as many chunks. So I definitely think that the idea is to go for as big a chunk as possible, because I think the most expensive thing about generating chunks at the moment is spooling up the fucking thread to do it. So we have to correct in like half a dozen different places that our chunk is. Actually might be just 2. So we've updated the chunk there and updated the chunk there. Everything else should use the constant, which means I should be able to do that. Oh, I need to go to the world and say it's going to take a while. Oops. Because I never made the map smaller again. I forgot to correct the map for the fact that we don't need to generate 10 chunks into the sky. We only need to generate 4 chunks into the sky. Somewhere in here. Spawn test map. 4. I should maybe make that like a calculates it at runtime, because it's going to take a really long time to generate that, because effectively we're generating like 10 times as many chunks as I did. Okay. Right. Look at it go. Look at it go. The chunks are big again. Now the real question becomes, what is our frame rate? Uncap the frame rate. Go. Move that out of the way. We're down to 20 FPS, but we are rendering the glorious massive world that is, our massive world. It's glorious. Oh. And I think we've lost that thing where when I unload and load big chunks of chunks, we suddenly have big frame spike drop because it's doing the proper texture loading. Yeah. Also, I feel like maybe maybe we have to correct the LOD, because I feel like also something about this tells me that the LOD is doing a lot of extra work. I do love this effect. It is actually kind of cool that it does this like weird stepped effect where it's sampling the full depth voxels, but because the mesh is only half it's like not rendering them like that. All right, kind of sick that we can do our like 16 by 16. Yeah. The point is that at the moment I'm not doing any kind of culling and I'm using Bevy stuff. So as soon as you're not looking at everything, you go up to 100 FPS. What's happening at the moment, because you can't actually see it, is that there are actually full rendered chunks here that are just empty. And so I can easily just tell it not to render those. Like we can just pass in a well, I guess technically we can just tell Bevy that if the chunk is air, we can just not do it. And so that's kind of the idea, is that we're going to use all Bevy stuff to make it fast to do stuff instead of me having to manually code things. So at the moment, it's hard to explain because you weren't here when we were doing it earlier. I guess I can just modify the shader to show them. Is if we just get rid of the discard like this, it'll show everything that we're rendering. Maybe it did not. No. We must be discarding it somewhere else. Here. Go to this discard. Right. As you can see, every single chunk is actually being rendered. And when we fly under the ground, if I turn back on like the discarding of air, but not discarding transparent voxels, you can actually see that every voxel is rendered underground. But the way that it's working is that the outer voxels are actually discarding. So when you're underground and you can't see shit, you get like a much higher FPS as well. Because it discards stuff a lot quicker. But we've got no optimization because these chunks that are air are actually being rendered. If you want to do full linear search, you can get basically full resolution as voxel depth in a single plane. Could even just drop down to making cubes that render. Yeah, also like it's not exactly like it's hard to maximize the fucking FPS in that. And like, let's see how many lines of code it takes me to double the FPS. Let's commit this. So we're gonna say this is I have no idea what we changed, but okay. What did we change? Let's work it out. So we oh yeah, we swapped to storage image, right? Or texture. So text. Okay, so we're using storage textures now. So let's see how many lines of code it takes to get the frame rate like something reasonable. My guess is 25. And we'll use get to work out how many it took. So what we need to do is go, when we generate a voxel, a chunk data. So chunk data is going to contain a is empty. Right. Then when we generate, we go down here and we say, well, I guess when we call empty, here, is empty true. All right, then we go generate and we say, hey, you start empty. And then we say, hey, when you say block, map descriptor, get block, set block, we say, ready? Yeah, so if block equals void return self dot block or equals 1. Or equals true. Sorry, true. Wait, other way. Is empty is false, and we need to start empty. Oh yeah, okay, never mind. It starts true. Right. So is empty true, and then we go back to here and we go FPS will go up only if chunk generation is dynamic with field of view, and also if each chunk, a bundle of chunks, maybe chunk generation of 1,000 having its own thread. So at the moment, every chunk gets its own thread and is done asynchronously in the background, which the FPS is not affected by the chunk generation. It does not care. The frame rate is completely independent of that. The frame rate is about how quickly the GPU can render things. And all I need to do is tell Bevy to stop sending every chunk to be rendered and only send the chunks that actually have voxels in them. So I'm just trying to work out what I need to do. So rendering, somewhere I generate the chunks, right? It's like down here. So we say mesh generate. No, it's not the block stuff. It's the update. Where's the update? Yeah, update. So somewhere in here we say mesh. So material data, add this. So we're gonna say, you can leave the offset. We're like, if chunk data is empty, what the fuck? No. So if not empty, do this. Well, I mean, technically you want to do that anyway. So I'm going to insert that at the end. So I'm going to say, apparently that field is private. Oh, no, it's not data. It's chunk dot is empty. We need to make that public so we can access it anyway. So we say if the chunk data is not empty, we add the image. Else we say commands dot entity id dot insert visibility hidden. Okay, and then we go. We needed to make chunk. Wait, chunk doesn't have it. It's chunk data. So I guess technically it is chunk.data. That's a bit weird. That should probably be stored on the chunk itself. That's a much better way of putting it. Anyway, but now I don't care because I just want to see like minimum number of lines, because moving that into a different type doesn't actually change the number of lines that this takes. Oh, it's a handle. God damn it, we have to do it before. Okay, fine. So technically we need it in both places then. Pub is underscore empty. Like this, then we say, hey, before we add that, we say your is empty is the chunk dot is empty, and then you are just this thing is empty. And then we just go like, what happens when we render this and go, because this should, in theory, just like not render the chunks. So then we just go back to debug and we turn on our, we uncap our FPS and turn this on. And we go, hundreds of FPS. And then we wait for everything to generate. And we go, hundreds of FPS. Where did they come from? Is it finished loading everything? So, maybe at 20 looking that way. But like it is, if I load the entire world, it's what, 20 FPS, 23 FPS. And then we go to Git. So what did Git reckon? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 15 lines. So let's stash all these changes and then let's relaunch the stash changes. And then we go fly out of the same spot, because the issue with that is that like technically the FPS started going down, but like it went to the same level, but I also like flew out so you could see the entire world, which means that Bevy wasn't culling anything. So it's gonna like debug and then turn this stuff on and go, did I fly like the wrong corner? Jeez. Come on, finish loading. So we're down to like what, 10 FPS, it's still not finished loading. So it's probably like here. So this is flickering between 10. So I doubled the FPS by effectively telling it don't render the empty chunks. We could also, for example, tell it to render chunks that are one solid block. Like there's a lot of chunks over here, like you can see. These ones are all like a solid block. This is all just solid stone. We could just tell it not to render those chunks the same way. Like at the moment, it's doing like a special case. Like we could just make it not. It would in no way be hard to again optimize even further by simply going, is this entire block, is this chunk solid? If so, render it with a different mesh. Because that's the great thing about this, is because we're not generating meshes on the fly. We can like do very heuristic things of only when we change the block do we try and work out what mesh to use. And it's like, theoretically, we could work out all sorts of different mesh rendering techniques to know which is mesh and which is not. Yeah, no, I know that they take compute, but my point being that like a completely empty mesh taking compute is very easy to get rid of. It's the hardest one. It's like you were saying, the stress test of if exactly one block exists in every chunk, we can't do that. So we double the FPS by simply not sending them to the GPU. It'd be even better if not to generate their fucking material, but that causes Bevy to crash. So, well, actually, I could probably just also do that. Shared it in the pipeline to cull entire planes as well. Yeah. That's already done. But Like, that's what I'm saying. We're using Bevy's built-in stuff. Like, the reason I'm trying the shader is because Bevy has all that shit built in. It's got frustum culling and everything. So if I just like come to the top of this mountain, because it's easy. So I get like 60 FPS looking at the world, and I look up and it's like 200 FPS. If I go below the world and look down, it's like, as soon as I get out of these chunks, it's going to zip up to like hundreds of FPS. Apparently not. Why does looking down not work? But looking up did. Basically, if I just like look away, it must be doing something else. Something else is rendering. Oh god, what did I run it in release mode? Fuck me. That's very slow. Like, that was chugging. Please run in release. But like, for a second there it was. Maybe I must have capped something out. Maybe something hit like the... So... Also, apparently my capping isn't working. Anyway, we're getting like 200 FPS. It is still rendering bits of the world, but like, if you're not looking at it, it just doesn't... Yeah, that's the other thing to remember, is that this is rendering, like, if it was Minecraft scale, hundreds of times bigger of a map, because what's Minecraft's fucking render distance? And its chunks are 16 by 16, and I'm rendering, what is my map? I've completely forgotten what size I made my map. My map currently is rendering into like 64 chunks, and each chunk is twice the size of a Minecraft chunk. So we're doing 32 by 32 by 64, which makes it like, those mountains over there are two times Minecraft's render distance away. Because I'm also 64 chunks, and my chunks are twice the size. So that's double Minecraft's render distance. Yeah, but not looking at the ground, I get 100 FPS. Looking at the ground, I get 20 FPS. And this is with my commit stashed that makes all the fucking invisible chunks rendered again. So if I go back to my thing and go, please restore my stash. Right, and then we rerun this. Is it 64 chunks? I want to say it's actually only 32 chunks render. It might load 64, but it doesn't render them. Anyway, my point being, like, if I turn my frame rate on, and then we uncap the frame rate, something's going on there because it keeps capping the frame rate. So now we're at like 300 FPS, not looking at the ground, and then we look at the ground and we're like 100 FPS, and then we don't look at the ground, we're at 200. I don't think the issue is the FPS. Like, it's already got the frustum culling and everything. The issue is that we are rendering worst case scenario at the moment because I'm fucking around. Like, I've done zero optimization outside of getting it to work. So like 100 FPS when you look straight down, you're looking at the distance, it's like 60 FPS, and then you go to really far distance, it's like 35 FPS. And it, like, there's no fog or anything. Like, if I put fog in and cut it at like its range distance of 64, like, that, as I said, like, so it's basically, I flew straight up. So we're standing in the center of the world. So it's 64 chunks away we can see. And we go calculate, and we go, and it's also not round, by the way. It's square, which means that, where is it? Where's the forage? I think that might be the forage. So that edge is 64 chunks, which means that edge is like 80, 90 chunks, because it's 40% further to the corner than it is to the edge. But if we go 64 times 32, it is 2 kilometers to that edge in Minecraft scale, 2,000 blocks away. I've got nothing to minimize it. So it's 4 times further the render distance of Minecraft, and I'm still getting 60 FPS. I mean, I get about 40 when I look in that direction. You're right, it's doing nothing else but rendering it. But here's the fun thing. Look at the GPU. Look at the CPU. 9% usage. I could simulate the entirety of Minecraft and not have my frame rate go down, because the cap is the GPU, not the CPU. The CPU is not doing anything. So I could do a hell of a lot more simulation. I could do a lot more culling and prepping stuff, and it would not touch my frame rate. Technically, I can also render a hell of a lot more, because you can see the GPU is not capped out. So I believe I could like make this like 64. The big issue we ran into before when we were doing this is we were running out of memory, because a huge portion of what's going on is the memory. it really runs out of memory. Like it was using 64 gigabytes of memory. But that's also still an optimization issue. Like it's not a... It's also, we're rendering way too many chunks. It caps the fuck out of my GPU while it renders. Or while it generates, not while it renders. Yeah. Generating slow, but again, no optimization has been put into that. I was literally just trying to make cool looking mountains, and so I'm using really inefficient code to make cool looking mountains. Look at it go. I stopped using 64 bytes per voxel when they're solid colors, so I just send a single byte now. I technically still send 4 because I actually send a 4-byte color, and I'm using the X channel to tell me what block it is, and I could, in theory, use I'm using the red channel to tell me the block type. I could use the green, blue, and alpha channels to store additional data about voxels, or I could just choose not to do that. Like I could just actually like try. So originally I was packing the voxels to try and reduce the memory. So we went from giving it a float per block down to giving it a U30 4 floats per block down to a single float per block. But then it was like pretty bad because it was using, like, again, we're trying to keep everything inside Bevy because Bevy's already really optimized for this kind of thing. So it was getting really slow because it was using my code to load and unload things from the GPU every time you looked around. So like it would freeze every time you looked away and back again and that kind of thing. So instead I load everything into a low resolution texture, like a low depth texture, and then it runs it normally. Look at that fucking valley, that generator. That's kind of cool. Yeah, so in theory, I could do that an extra step of saying there's only 256 possible block types, give each chunk 256 blocks that it could possibly hold, but that might, again, make the chunk generation a little bit slower. But my plan is also not to make a modifiable world, because even though rendering-wise it wouldn't make a difference, I would think it would be better to try and be like, the game I'm trying to make doesn't lean itself to being able to edit the world, and have the edit stay persistent, I guess. But yeah, so the idea being that I could, in theory, shrink it 4 times again by instead packing 4 adjacent voxels into the same texture. So instead, it's like the red channel is one voxel, the blue channel is another voxel, the green channel is a voxel, and the W channel is a voxel. I don't know if we'll do that, because I do like the idea of, one, being able to have more than 256 blocks in a chunk, like more than 256 different block types or colors or whatever, however we want to distinguish it, and also passing in certain information, like maybe having blocks be able to have different transparencies without being a different block, or just different things like that. So I think this is probably the memory level I'm going to stay at. But even now, we're rendering a world that is significantly larger than any Minecraft world that's ever going to get visualized in one go. Technically, we are doing LOD stuff where 32 blocks, because I think it's Minecraft's render distance. We drop down the LOD. It might be 16. But like, the idea being that when the LOD drops, the resolution of these textures, that's why they look so funny, is these meshes that are further away, because at the moment LOD doesn't care about where the player is standing. These ones are actually rendering 16 by 16 blocks. So it's only actually rendering the outside of a chunk. I guess it's 2 per chunk. So I don't know, 8 per chunk. It's 4 per layer and 2 layers. So it's basically rendering way less material per chunk because it's further away from the player. I do need some better sampling, because when I was doing it originally, it was averaging the color, and that resulted in like really motley colors over here as the dirt and the grass blended together. But yeah, like, this is with no real thought towards optimization outside of, like, as I say, culling anything that's not rendering a certain way. We could, in theory, come up with a whole different bunch of meshes, because we don't have to transfer the meshes all the time, which means they all use the same mesh. It's only loaded onto the GPU once. How is the GPU doing for memory to work out if we can make the map even bigger again? Oh, look, it's using what, like 8 gig? Right, so we could theoretically double the size of this map, which, not in one direction. We could double the area of the map, so that's only like a 25% growth. But the entire map could get way bigger, and it still would take very little extra memory. Where do we do that? The issue is I need some kind of way of generating the chunks more efficiently, because all it does is peg the fuck out of my GPU. Fucking 64. No, don't make the map 64 high. Ugh. 64 by 64. And I think we could go like maybe 4 blocks underground too. Yeah, because like again, I was making each chunk is so what was the math we had? So each chunk was 32 by 32 by 32. So each chunk has 32,000 blocks in it, and then each chunk was consisting of 4 floats. Each voxel was 4 floats, and each float was 4 bytes. So each voxel was 500 kilobytes of memory, and we were rendering a world that was 128 by 128 by 128 by 128. That's the size of the world we're rendering that now by 10. So that's how much memory it would have taken, which is bytes, kilo, mega, giga, tera. So it would have taken a petabyte to be able to store it all. But now we can divide that by, now it's 4 per, so I think we divide by 16. So now it only take this much, which maybe I've got my math wrong, and it's going to take way less than that, because I think we're also not rendering air anymore, which means like we actually don't send that to the GPU anymore. So we'll see how much memory this takes. Something tells me a lot, but because again, you notice in my optimization code, I don't think I got the math wrong. I think part of the optimization is that we I divided by 16. So it was 32 bytes, right? So it's 4, yeah, it's 4 times 4, 16 bytes. There were 4 floats, 4 bytes per float. So 16 times 32 times 32 times 32. So that's how many, 500 kilobytes per chunk, and then there were 32 by 32 by 30 by 16. No, we were doing 32 by 32 by 32 times 32 times 5, was it? Times, it's just 500,000 because that's what it was, close enough. I don't care about the exact. Maybe it was this. So that's mega kilo. No, because that would only be 2 gigabytes. It's definitely somewhere else. Missing an order of magnitude somewhere. But anyway, it was crashing before it got to size. It would run out of memory. So we then had to keep cutting the world down. So I think we ended up going down to like 8 by 32 or 8 by 128 so that we could test the distance. Oh, because I did 32, that's why. So it'd be at least double that again. The 500k per chunk was correct, but it was 128 100. That's no. Did I do 428s? Because it was a 60. It was negative 64 to positive 64, negative 64 to positive 64. Well, next is like I was saying, optimize it a little bit so it doesn't use so much memory. Also, just in case you don't know, I think I have a faulty RAM card, and I believe I probably used a little too much RAM there, and as soon as it touched the faulty section of the card, it crashed my whole computer. But that's a me issue. Normally computers don't crash when you use 100% of the RAM. It's my computer specifically has something wrong. It keeps crashing. Like in certain games, will just crash. So don't mind the random crash in the middle of the stream. That I need to swap my RAM cards out. I've literally got 128 gigabytes of brand new RAM sitting on my desk that I haven't put in and had for like 6 months because I want to make a video about how much the speed of RAM and the quantity of RAM in fact affects compile times, and so I need to actually record that stuff before I rip the RAM out, because otherwise, you know, I have to restart my whole computer to be able to put the RAM back in, and yeah. So anyway, oh, I should probably announce that the fucking streaming. I keep forgetting to do that. Oop. Also, what is the time? It is 12 o'clock. I probably should have had lunch. I'm just gonna copy this. I'm gonna stream for, let's say, like 2 hours more most. I need to set an alarm for that. So I'm gonna set an alarm. I'm not streaming any more than 2 hours because I actually gotta stop forgetting to have lunch because I'm streaming. It's yeah. All right. So it's gonna done this and I'm gonna turn that off. All right, hour and 40 minutes left. Cool. So I'm just gonna copy this. Did it only disconnect me after I logged back in? That is kind of fucking stupid. It's probably only because it actually detected that I had gone, like that the signal had lost when it reconnected and it said, hey, I'm not connected to you anymore. Go back to Discord, go to announcements, and go at here. 2 hours left. Yeah, I said that, but as I say, I've actually set an alarm this time. I actually need to stop skipping lunch. I'm just gonna ping everyone on the Discord if they want to come join the last 2 hours. Okay, so right, yeah. So next is it's just to, I guess, again, try and oh no, don't run it again. Stop. I didn't turn the map size back down. So conclusion, don't render a fucking map that big. So we can probably go like, with 32 worked, it's at 64. I think maybe we're just going to scale the map down to 64, 32 by 32. We can say like, that's twice Minecraft's render distance because our chunks are twice the size. Yeah, so what I'm thinking is we can pretty easily, because of how my chunk logic works, well, fixing LOD would probably also be smart, but in our thing here, we have a main mesh and then meshes, which is our LOD. I want to change this out to a hash map, actually. So we're going to say, maybe a small map. Small, I don't know, we're going to do a hash map because I can't be bothered adding more things. Hash map. So we're going to go hash map LOD like this, because then I can call different LODs different things. So LODs here, we're going to go, hey, this, and this we're going to say, you're a hash map, and then your LOD insert, and then LOD. So this makes the different distance LODs. But cheeky, we can go about and make it like, and also it means I don't need a 0. Originally, I would like have 2 copies of the LOD because it's kind of difficult to have the LOD and then have a different LOD. So self meshes get, and then get LOD and plus the LOD increment. So first off, let's check that worked, because you know, there's no point breaking things. So we go open all this. I can reopen everything because my fucking stream crashed. My own computer crashed. All right, so fly up and go. Okay. So the LED stuff's still working. LED stuff's still working. Lovely, lovely, lovely. Right. So we're gonna go. Don't render empty chunks. Push that up for anyone that cares to read that. So we're not rendering empty chunks. So now I'm going to add an LOD, and this LOD is going to be called like solid. Right. And the solid LOD is going to have a step of, I guess, 16. No, chunk size. Maybe. I don't know. Maybe it shouldn't. Maybe it should have an LOD of 1. Yeah, we'll have an LOD of 1 because we don't want to do. Yeah, I know, right? It's onto me. It knows that fucking VS Code needs to be restarted all the time. So we have this, and so we're gonna have the solid LED. So the solid LED, we get to have fun and got a chunk, and then we should probably have like a separate module for like meshes of the chunks because I keep making more of them. So like we have the. This is more private than its fucking type. What do you mean? Map LED. Yeah, but LED is LED is not public apparently. Fuck you. Pub LED. Alright, so we go to here and we go, hey, can I say like constant? I don't think I can make this constant. No, because it needs access to vectors. So make solid mesh. I guess we call it bake. It's no. We call make bake mesh. Anyway, that's not how this works. Thank you. Let mute mesh equals mesh new triangle list render. Because the other thing is there's also things like potentially other things would be faster. Thank you AI for so bottom left, bottom left, bottom left, bottom left, top left, bottom left, bottom yeah, that seems right. Anyway. I'm so curious about how does the AI get this? Does the AI one-shot it? We will find out. Dun, 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 dun. Okay. So we're going to say, hey, so LED step of one is one, solid. When we say when say LEDs dot insert solid, make solid mesh. Right, so basically that mesh should translate to just being the solid outside of a cube. I think the math just occurred to me that oh no, because fucking square. Can we be cheeky and be like Bevy? Actually, no, I don't think we can because Bevy won't render them with the right normals. Maybe it will. Maybe it won't. I don't know. I don't want to risk it. Anyway, we make that mesh, and then that'll be that mesh. Well, like, the trick with this is that it would take me less time to review it by hand. Like, the trick is to remember that I did it with AI. But, like, it will take me less time to review this with hand than it would take me to work out from scratch what it should have been. Because, let's face it, we're doing that anyway. This is also already very wrong because, let's face it, it's using the same. So there should be 8 points, right? 1, 2, 3, 4, 5. Yeah. So these points aren't necessarily correct. In a very much, there should either be even more points. Anyway, I'm not going to fuck with the overlapping points. I'm going to let the AI knows what it's doing. We're just going to pretend that the AI knows what it's doing, right? Because it's written pseudo-correct code, but I feel like I'm probably better off just bringing the Bevy square if this doesn't work and just using the Bevy square, because at least it'll have the right normals. Maybe I should just fucking do that. Yeah, we'll just start with that, because then we'll know it works. So we're going to say Bevy, okay, we're going to say cuboid, cuboid, from length 2, maybe, I don't know. Into. Cool. So I think it's 2 because I want it to go from -1 to 1 because that's how the other mesh works. So it just means we don't need to fuck around with that. Whereas if we set length of 1, it would go from -1/2 to 1/2. Anyway. Yeah, exactly. They are like, it put the right code there. Like the code, there was nothing wrong with that code except that it was assuming that it was only Z faces for some reason. And I wasn't gonna fucking try and trick the AI into putting all of the faces there, and I can't be bothered dealing with the needing. You either need to fuck with the normal so that they will point out like we were trying to do the other day, or you need to make 6 copies of all the fucking vertices or whatever, so that you can have a front back face, a left right face, a top bottom face, instead of like correcting the normals so that all the faces point in the right direction. Anyway, so we're gonna have our chunk, and our chunk is gonna have like a I guess pub LOD. I'm gonna say LOD hint. And we can say LOD. So the LOD hint is going to be like, we're not going to use the LOD unless it matches a certain specific rule of LOD. The idea being that, so we can say, because I think technically the way we'd want to do the hint is saying like, when we say, get to here, we can go like pub, calc, we'll just call LOD hint. We'll call it LOD hint. LOD hint. Right? And then it's going to do all the different stuff that it might do. And then you don't have an LED hint, so shut the fuck up. So we're going to say like for be in self.blocks.iter if what? No. Let solid equal self.blocks.iter. Sure. Any block does not. That's not what solid means. Not. Right. So self.iter block any equals, so, and then if solid, return solid, otherwise LED1. Right. So that's its LED hint. And then we can go down here and we can go, at some point I make a chunk and say, hey, UR is empty. And then we're going to say LED hint and then starter.LED hint. So basically just iterate through all the LED and if any of them, which actually means we could do cheekier stuff because at the moment, effectively, if you set a block to solid, it'll never be able to detect that it's not solid. So I guess technically we could return so solid, and then we're going to say let empty empty equals self.isEmpty. Self dot, well, it's more like self dot blocks dot iter or any. Again, we're doing this weird not anything, and it's like any block not equal to void. You're empty, and then else if empty. We're just going to have an LOD empty as well. Like LOD empty. Because then like we don't need to keep storing booleans all over the place. So we can say like, hey, you're not is empty anymore. You just have that data. And then we have to go to LOD and we have to give LOD an empty. Empty. I'm also going to maybe say that the empty LED has a LED. I'm going to say that everything has an LED step of 1 if it's not specified otherwise, because that means it's like it never actually chunks wrong. Like the idea is if we fuck up the LED and forget to add one, it'll still work. It'll just render all of the pixels and won't therefore like blend anything. All right, so you don't have an is empty. You have an LED hint. Thank you. Where's that? So you don't have an is empty. You have an LED hint. I'd also like to say that I predicted that it would take me 25 lines to reduce all the things, and it took me like 12. So I was not actually that far off with like my prediction being like it's not going to take that many lines of code to fix it. Anyway, so set block and then this. And we don't care. We're going to stop querying about that because, you know, we detect it when it's done, which technically is a very slow way of doing it, but it's a very robust way of doing it rather than keeping track and being like, if it ever stops being empty, it can never be empty again. So anyway, we're going to say if maybe match chunk.lod hint, and we can say, hey, solid. That's not what that means, but anyway. You are going to say commands dot entity id dot insert mesh 3D self dot await. The fuck are you self awaiting? Because it's mesh generator. Apparently await's available in anything. Mesh generator dot get mesh LOD solid. Right. And then empty is going to do something apparently. Fucking commands dot entity id dot insert. Again, without world modification, we can literally just hide it, but it would probably be smarter to bring in the visibility and update it. Okay. The answer is fuck you. The rest of them are just not going to do anything. Maybe. Because everything else should just be an LED hint 1. We're going to say let chunk entity entity equals command dot entity entity ID, and then we can cut down on the number of calls to here, and we're going to say, hey, chunk entity insert this mesh, chunk entity insert this mesh, and then you do nothing. I guess technically these need semicolons then. The worst. I guess actually technically we can just be boring and be like, hey, so chunk it, chunk, no, don't chunk entity, and then we can like dot insert this like this. Immutable reference to that. Then we just make immutable. And then, hey, can I borrow immutable? What do you fucking mean? Can I borrow because it's already borrowed as mutable as is? The fuck do you mean? Why am I borrowing you? Where am I borrowing you? Task strain. You're the worst. Fuck you, I'm gonna do my little switchy words when I say let tasks equal mem take that, then we say tasks drain, and I'm trying to do it with another middle here, and then we go down here and we say, hey, mesh train tasks equals keep Well, I mean, if you're gonna do that, we might as well just fucking get rid of keep then. And just say, not tasks, it's like mesh generator dot insert dot tasks. This is like one of those annoying like borrow checker things where it's like, hey, you can't do that, and I'm like, okay, fine, but I won't do that. So image, like chunk image, material, and chunk image, offset. I don't know. Turtle, as a C++ developer, I know this would definitely be one of those things. People go, oh, Rust, you know, borrow checker. But like, wouldn't you have to do this anyway in C++, where I'm iterating through it, and I'm also putting them back onto it, like I'm draining. I'm doing a draining iterator, and then reinserting. So I would actually not be able to modify in place, and the compile, like the Rust's borrow checker is saying, hey, what you're doing is not allowed. So I have to do it, but I feel like in C++ you'd still have to do what I did, which is store it somewhere else with like a dummy one storing and then refill it. Like that's something you'd have to do. It's just it's not enforced. Like C++ will just let you forget to do it. Anyway, what am I doing with this image? So we're chunk data generate task insert. Okay, so somewhere down here we have to be like material dot color texture. But can you remove the add to the end just fine? Because it wouldn't reverse iterator have the issue of if you remove something from the end, you have to shuffle all the elements down. Or if you remove something from the middle, like once you've gone through, you have to shuffle everything down. So you would, technically the correct way to do it is to have two iterators so that like one goes into the other and you never reallocate. But like it needs to shuffle at some point. So technically you'd want to go from the beginning, because then if you remove it, you just go to the next one knowing where you removed it from, and then you insert them back in from where you removed them. Yeah, that's what I mean. Like, Rust forces you to show the compiler it's safe, whereas I feel like most C developers, at least, like definitely at C level, would very much just be like, nah, I'll just use some pointer math. Not color texture, data. No, you didn't even do the fucking sum. Yeah, but that's what I mean, is that you run into the issue of if you because what I'm doing at the moment, I'm being lazy and reinserting, but I'm effectively checking to see if a task is finished and removing it from the hash map if it's finished, which means that for like efficient memory storage and that, it would want to condense the hash map back down. Or maybe not though, because it is, you know, it's literally a hash map, but like, so you'd want to start from the beginning, because in theory, nothing's finished and nothing moves. And if something has finished, you'd keep a pointer to like the filled part of the vector. And then when you find another one that's not finished, you'd write it to the next element of the filled section, because then you're never actually going over memory that you care about. You can just clobber the memory as you go, with like basically condensing it down, and then you update your length at the end of how many you wrote back into the list. Like, you could do it faster. Because I feel like going backwards would mean that at the end you'd then have to condense everything, move it all back down, and to turn it back into a packed vector. Oh, okay. Yeah, that's another interesting thing that I have noticed about the C and C++ versus Rust debate, is they go, oh, but like the compiler enforces us to use the new stuff. Where it's like, yeah, but C is just as safe if you use the actual abstractions. Now, to remember what I did, I don't actually know. I guess the only way to check to see if what I did actually changed anything is to go inside one of these and go, hey, look. It's solid, so it's not rendering every voxel inside anymore. Now it just renders like much bigger voxels, which in theory we could do for air as well, because it would result in basically air being rendered as much smaller chunks. The idea of this is it does less culling, because it's, instead of having 64 faces per block, like per chunk per thing, it only has like per plane, I guess is the word. So what the fuck's happening here? I'm just gonna chalk that up to LOD shit not working properly. Anyway, I find it interesting that this is down to like 15 FPS. Wait, maybe I should, you know, empty is hidden and solid is replaced as solid. So if I just said like, hey, can I comment these two lines out? We need to compare somehow, because it is seeded, if I remember. So we're getting like 15 FPS if we do this. So 50 to 60. Maybe we update our FPS timer to actually include more information. We need to also work out which one we fly away from. But anyway, so we're getting 15 to 16. If I turn that off, which is both hiding empty chunks and, because I feel like I'm doing something wrong, that it's causing it to render really slowly. Like, I didn't actually change anything. Maybe it's because they're not all the same mesh anymore, and it's actually worse to render different meshes. But what we need to do is go to our debug terminal here and go, no, this is a debug queue. It's UI debug, isn't it? Yep. So we did the FPS text, and then the FPS text is gonna this is for cleaning it up, setting it up. Yep. Okay. So spawn FPS text. I'm gonna go with something like spawn FPS text 1010, like that. Don't have the text inside. Don't have the themes text. I'm gonna say children. To be I'm yeah, so that's not being weird, that's just being a rough developer. that's the difference. It's like, you're not a weird C developer, you're just a Rust developer. See, if you didn't like that the compiler was trying to enforce things, you'd be a C developer and you would stay in C, but you're like, I don't like that it's doing that, so let me go to the language that forces it on me. So I'm gonna just do this because what I can do is go give me my FPS, give me my, apparently I had some weird thing copied in my clipboard. That's weird. I guess I moved that, I didn't copy paste it, so that kind of makes sense. Anyway, so we have our FPS and then we have our FPS A and our FPS S. I'm just being lazy, naming them that, but anyway. So we're gonna then say, hey, iterate through text. Okay, so it's actually more like, hey, grab me FPS things, and we're gonna grab the children, please, thank you. And then we say, hey, then we say, FPS, oh, right, query, mute text, I guess, yeah, sure, just all text, sure. And then we say, let text equal, let element, I'm trying to be lazy here, not working, let FPS equals text dot, alright, we actually let diagnostic equal diagnostics get FPS, reference to diagnostic path. Right, so now we have our diagnostic, and then we can say text dot get underscore mute FPS root, something like that, so it's a little easier to FPS root 0, else I guess return, we're gonna warn, here's an error, this is an error, FPS text entity not was despawned. Sure. It must be okay. Let's okay. There we go. Let's mute, okay. And mute. Oh, brain's not keeping up today. This is why I should not skip lunch. That's why we're only doing another hour and a half of stream at most. Okay. Then A and okay. So we grab these elements and then we say, hey, FPS dot zero equals format FPS, so value unwrap or default. Can we, I was gonna say unwrap or NAND, but you know they won't work. All right, and there's FPA unwrap or average and then smooth. And didn't. All right, apparently you have to do these in between because we can only borrow up mutually once at a time. You know. I feel it's trying to be a bit too... That's my thing is yeah, I agree with you that like Rust can feel very verbose, but my thinking also is a lot of the time when Rust is being verbose, it's saying, hey, like right now you feel like you should know these types, but actually you can get to this location without being able to know these types. So Rust will infer if you're like, if you declare something and then declare it something else, it's like, well, the function signature tells you what it is returning and what it should be turning into. Rust will do all that. Like generics are amazing for Rust not needing to declare shit because it just does it. The issue is you can't use a generic that you don't actually ever hard code because someone else's code is doing it. Yeah, I know. That's actually why I'm Rust and not C++, is when I tried to learn C++, I couldn't even get the thing to fucking compile because I couldn't work out CMake, and nobody told me that I needed to work out CMake. And then so when I'm looking up C++, I'm going, oh, like, you know, gotta learn this and learn that. And I was like, I can't even get this thing to fucking compile. And then I went to Rust and went, oh, well, look at Rust. And it just says, yeah, type this line into the terminal and you're done. I'm like, what the fuck? Like, nobody told me I needed to go Google what CMake was to learn how to make a C fucking repository, like to make a C project. It was just like, oh yeah, you just do C++. Yeah, you'll be right. I was like, what the fuck? Anyway, now we should probably like maybe flex direction. Gotta like configure it a little bit. So like flex direction columns, flex wrap, and then it's like flex base. No, it's like, I don't remember how to do it. There's a way you can be like flex wrap like at the end of any child or whatever. I don't know. Anyway, so now we can see that the average FPS is 38, which is going to be like a lot more useful than just being like, it's flickering between these two values. The issue with the average is a little bit long. It takes a long, especially because as the FPS goes down, the average is sampled less frequently. Anyway, so the average FPS for looking at the whole map, I'm going to say basically opposite the mountains is how we're going to determine that we're in the same corner every time. So it's about 13 FPS. So the next is to come in here and go, okay, so if we say fuck off the air, which is here, so we're going to say, hey, hide empty. Yeah, but that's my point, is that you at the very least, back in those days, they gave you a book that told you how to start. These days, they're like, yeah, you just get a C project. I didn't even know that the CMake was a thing. Like, reading the internet didn't tell me shit. If someone gave me a book that told me how to do it, I wouldn't have had a problem. I think it was this corner, wasn't it? Maybe it was this corner. I don't know. I don't know which corner I was supposed to be on. It's this corner, because it's in the opposite. Like, you know what I mean? Like, the book, at least, you can expect that the book will be like, hey, you need to get, like, CMake set up and tell you how to set up CMake. Whereas with the internet, everyone just sort of assumes that you know how to do it. Anyway, so we gained about 3 FPS, I'm going to say, because we're at 17. So we were at 13, now we're at 17. So by not rendering air, we go from 13 to 17. Okay, it's pretty good, pretty good. I don't know what that is. That's I want to say a 40% improvement or something. We can calculate that. Yep, calculator. Don't randomly type fucking CA in my code. It's something like, we say 17 divided by 13. It's a 30% frame rate increase by simply not rendering empty ones. So shush with you. We don't want to render empty ones. We're not rendering empty ones anymore. And then we're going to say, how much do we save by not rendering solid ones? I probably should have actually done the comparison like while rendering empty, because technically, I believe that empty. Oh no, because the air. So we could actually check effectively doing both. You know what's interesting is that the reduced frame rate results in chunks generating slower, not because they're actually generating, like, it affects the chunk generation code, but because we queue less to be generated. So it basically doesn't peg the cores at 100% because it needs at least one frame to queue the next one to render. Now, why does it feel like it's slower to render solid? All right, when you come over here, we need to render the entire world, and then we need to go, okay. So, do we save that much? We get about, we lose an FPS. So, that's strange. Why do we lose an FPS? Is it because hidden, not hidden thing? Like, is it that they're eating each other's lunch and it's technically slightly slower to have two, like a solid mesh and a not solid mesh? That is interesting. Also, technically with that means we can tweak the LOD when we do different meshes as well. Is it? Oh, okay. No, because it was 13 when we weren't rendering air, and then it's 17 when we're rendering air. When we're not rendering air, and it's 16 when we're... I thought that's how I was... Maybe I'm just messing up the... like mentally like what I did, but I thought it was we were getting like 13 here. So 13 when we're just rendering solids. The other question is it actually no, we checked it was. So oh, you know what it probably is? It's that fixed pipeline thing where so we're getting 13 FPS like this, and if I turn this off, I think we're still getting 13 FPS. It's that our shader isn't the bottleneck, and therefore it's not actually that's causing our issue. That's what my guess is. So not rendering air is a massive improvement because it saves a whole bunch of chunks, but not rendering, like not culling a bunch of stuff is like I was saying. If it culls early, it doesn't actually matter. So really, it's only saving us memory, and it's probably actually losing us a little bit of frame because it has to now run like 2 batches, whereas Bevy can batch absolutely like crazy when we have everything is exactly the same mesh. But as soon as we step to, oh, but now we have a different mesh, it loses a little bit of culling, which also might become a little bit of a ironic thing about LOD may actually technically be lowering our frame rate because it means that it has to do it less batches because it does have to do it in every pass, which would be interesting. That would actually be really interesting to know. To see what I mean? Like we actually get better FPS not doing the solid. So the solid blocks are lowering our FPS, which to some extent implies that our entire LOD is lowering our fucking dummy image. So LED step, chunk. That or I'm passing in the wrong texture maybe? No, I don't think so. Where do we do it? Custom material, LED, alpha. Where do we pass in the mesh? Mesh is here, and the mesh is to get the LED. So I'm going to say that we're just going to pass in LED. 1. Right. So what I'm curious about is that's kind of implying that Bevy is having to not batch every single one, and not batching every single chunk is actually costing us frames because not enough of the chunks are completely full, which implies that the LOD may actually cost us frame rate if we have too many LODs. So what I'm basically checking here is if we turn off all the LODs, what is our frame rate? The answer appears to be increased. It's still technically going down because it's rendering more chunks, but like the fact that it's slightly going up. Well, yeah, technically, yeah, so look at it. So turning off all the LOD code and we still render at the same fucking frame rate. And I think part of that, actually, technically we gained a frame, didn't we? Because it was like 13, now it's like 13 and a half. So what's happening is that Bevy is batching every single mesh at the same time now. So our LOD comes in and actually starts reducing the number of chunks that Bevy can batch at the same time, therefore effectively reducing the frame rate. Because even though we have less work, we have to do it in 2 goes, and that GPU likes doing the same thing a lot. So what I am curious about though is, does this make whole chunks worthwhile? Is that like, now that we're not effectively cannibalizing our own optimization, I feel like the LOD might be one of those, we really have to fine tune the distance that the LOD kicks in. Because I swear the LOD has to have an improvement because of what it's doing. Like the fact that it's just effectively cutting a whole bunch of information out. I mean, the LOD is doing something. It's like, it's actually really working. But it appears that like the additional meshes are not worth the sacrifice that the LOD of the LOD. Like the LOD might, but that also means that like an LOD of 2 might be good, but it just means that like the LOD of 2 needs to start at like 64 chunks away, and it's just about letting you like basically render even fucking massive of a maps. Look at how quickly the solid ones like come blocking it. Right.
The other issue is I'm also doing a very non-scientific test of like who fucking knows about this. Yeah, it's legitimately slower to have more than one mesh. God damn it. That's so fucking annoying. I guess this is what happens when the bottleneck is the fucking fixed pipeline. Because our shader is effectively doing nothing and that the fixed pipeline is discarding everything and doing all that, there's no point having the LOD have their own meshes, because the additional mesh means that it has to do it in 2 batches. And that fucking slows down the fucking fixed pipeline, because now it has to flush the pipeline and start again. The fuck? Like, I feel like we could make this faster if we controlled it. Like, if we went in and told Bevy how to go about, like, rendering, like optimizing rendering, and batching. If we were manually batching, we could probably make this faster. But fuck, I'm so annoyed. Technically, this is nicer because it means when I fly through the ground, it doesn't fucking like obliterate my eyeballs, because they're actually bigger chunks. But the fact that it's... Oh, actually, that's an interesting thing we should probably test. Is that it does appear that the bigger chunks probably have a nicer like impact on frame rate. But maybe not. Maybe it legitimately does nothing. We should probably make like a slightly more scientific test of like spawning and rendering a specific scene, but... No, so air culling is Bevy before it sends it to the GPU. So technically, air culling speeds things up because Bevy doesn't actually tell it to render the air at all. So the air is actually not getting batched as something else, whereas the solid blocks are a separate pipeline that Bevy is running. Like, it has to flush everything and then go, these meshes, and then it flushes it. So technically, it might even be possible, like, we could actually, like, again, we could optimize this and actually make this have an impact, but we'd have to go in and, like, run our own pipeline that can batch the meshes together or something. Because, like, that's what's happening. It's basically Bevy is going, hey, these 2 chunks have the same mesh, so I can run them at the same time. So maybe if we made the ones that have the same mesh use the same material, because at the moment the textures are attached to the materials, so each of them have different materials. So if they had the same mesh and same material, Bevy could maybe batch them better. But at the moment, it's very much that it's batching them all together because they all have the same mesh and different materials. So it just loads like X number of materials into the GPU, which is our voxel data, and then runs them all in parallel because they all have the same mesh. So Bevy goes, hey, these can be batched together. We don't need to load. Whereas as soon as we get a second mesh, now it can't batch these together, which means that it ends up being slower. And in theory, like in a bigger world, that slowdown would probably be less noticeable and maybe even swap into being beneficial in the sense of like, I'm trying to think how to explain it. As there's more and more chunks, the 2 pipelines flushing, that like the cost of flushing the pipelines and not batching and having that second batch would become less and less proportional to the number of extra chunks that it would be able to render. Where, yeah, and so the reason the air doesn't have the same thing is like I was saying, the air actually, we tell Bevy that they're hidden, they're invisible. That's what the hidden does. So we're actually telling Bevy, don't render them at all, which makes me think that maybe it's worth leaving it in, because it could be that we're actually hitting the worst case scenario, which is none of the solid blocks are visible and therefore are purely a waste of time. And therefore, like, the second pipeline basically is doing nothing because they're immediately getting culled. So they can't run in parallel. But they probably have a huge impact when most of our screen is filled by the chunks. But I do find that the LOD drop-off is fucking stupid, where it's not worth doing the LOD because it's actually faster to not chunk the LOD. That is the most, like, hilariously stupid thing I've ever seen. Where we're actually better off just letting the GPU do its own thing than fucking trying to... But that's where I guess the question comes down. It's like standing on this mountain, because this is like a way of being like, we can come to the same place and get like basically the same amount of viewers. We just stand on this mountain and we get like a consistent 40 FPS. If I look at those other mountains, we get about 30 FPS, which I guess is proportional to the amount of air that's in the way. So maybe we should fly higher. So we're getting like 45 FPS on average, like maybe 40 turning around. Yeah, so we'll call it 40. And then if I turn on or turn off solid culling and fly to the top of the mountain, we'll see what FPS we get. And see if it's 40 as we spin in a circle. I feel like it might need a slightly more scientific thing of like maybe setting up like a toggle to make us turn in a perfect speed circle or something so we can actually get a nice average or something like that. I don't know. Where is that mountain? Snowy mountain. We climb to... Oh. I probably also should slow down the speed that it fucking zips off at, but you know, can't be bothered. Another thing that's also probably killing our frame rate is this world inspector, because Bevy GUI is fucking atrociously bad when it's slow. But as you'll notice, we're getting like 30 FPS on average. So it definitely helps if you're not rendering the entire world. It's probably quicker for Bevy to load and unload the solid blocks than it is to not unload the solid blocks, and therefore the FPS that or oh no, it was probably doing chunk generation. So now we're back down to 40. It does feel like it's pretty close to the same, like average FPS, which it's fucking like about a frame faster. God damn it. I still feel like this is probably better. Like in that, like it will give us more bottleneck somewhere else. The chunk is air. Well, that's the thing, is it shouldn't actually be rechecking if the chunk's air, because the LOD hint, again, this is about like not allowing the map to be modified. The LOD hint is saved on the chunk itself somewhere. So technically, yeah, it'll slow the fuck down as we start generating more world bits and as we get closer and closer to the edge of the world. But the actual chunk data isn't moving. We're just swapping the pointer around, so we never recalculate any of that stuff. Technically, I should probably be doing a lot of this, like new tasks, old tasks stuff. Wait a second. I don't do that anyway. God damn it. Stop allocating memory. I kind of want you to do more stuff, so I'm going to say, hey, tasks. So we're going to take this one, and then it's fucking new tasks. And we insert. So don't take, swap. Swap tasks and new tasks. So if you're not sure, oh, I know how to take it. Take tasks. So we take tasks. So what this is doing is we're taking the pointer that points to our tasks and we're replacing it with a pointer to an unallocated hash map, basically a default hash map which is unallocated. We then drain the current hash map and we insert into new tasks. Then at the bottom we have to say that mesh generator dot tasks. No, wait. std mem swap. So we're going to swap tasks and new tasks. So now the unallocated one is in new tasks. And then we say that mesh generator dot new tasks equals tasks. This should mean that we don't need to reallocate. Yeah, exactly. Exactly. It'll have to recalculate that, but fuck you. Annoying. So we have to say swap. So we have to swap new tasks and tasks. Right, so now new tasks is empty and tasks is new tasks, and then we say tasks. Tasks equal tasks. I gotta make sure I got this in the right order. This is one of those gotta fucking tested things. But basically this is meaning we don't reallocate memory every time we fucking generate a cluster of chunks. We also probably should up the number of maximum chunk tasks, because I think that's part of why the world's taking so goddamn long to load, is that we're only loading 96 chunks per, which it may actually be able to do. It's probably spooling up a lot of tasks, and then it's effectively, once it gets so far out, it just actually takes so fucking long because it needs to generate so many chunks. All right, so I'm gonna go, hey, if mesh.tasks.len is greater than mesh tasks len is greater than maximum chunk task. Where are we setting maximum chunk tasks? Probably in from world. So we probably need to set this to like maybe 250. and just like that should mean that it's always spooled up. But even then, I think we're spawning like 4 times as many as we have. So we could also like maybe tell it not to use every single core on my grid. I think I already have actually. I think it's only 75 threads. It was 75% thread count. So the maximum number of threads is infinite, but it's only allowed to use 75% of them, which means that the mesh generation shouldn't be able to kill the game logic, because technically the async shit's not. It can't consume all of the chunks. I don't know if it's generating any faster. It just has more of a buffer. Interesting. Another reason is this, it stops it from being able to eventually like start generating chunks that are too far away. I also feel like we should probably put caves back in, but I guess that technically the max is just an arbitrary number. It's just about making sure that it can't generate like technically the way to calculate the max would be to say like what is 16 times 16 times 16 and say like you can't generate more than that at a time. Or no, it wouldn't be 16. It'd be like maybe 5 times 5. I have a calculator open. The maximum should be like 5 times 5 times 5. So 125, because it means that it can't start queuing more chunks until it's generated effectively a 5 by 5 by 5 chunk around the player. Because that's kind of why I had to put the max on, is because if it queues all of them, it can then pick, because I don't think it goes, oh, first in, first out with tasks. So what it'll do is it'll grab a task and it might end up generating a task that's like generate a chunk that's hundreds of blocks from the player, and therefore you end up with the world getting all clustered again. Like if I just turn it off, I'm pretty sure you'll see like the specific number is actually not that important. Like if I just turn it off, it'll just stop generating radially like it does from the center of the world outwards. It'll just start generating randomly, which technically we might even want to turn this down even lower, because once the player starts being able to move around and generate new chunks, see how you like there's holes in the world? So once the player starts moving around, what you don't want is it to have chunks queued for like later, I guess is the way to look at it. Like you don't want it to be generating chunks for when the player is going like old data, I guess, is like the player's moving away from those chunks, but yet they're still in the queue because it queued them, but now they would have been removed from the queue if it hadn't. Anyway, we'll turn that back on. That's just about keeping them, making sure that the chunk generation goes from the middle out, is they can't queue too much shit up. All right, so he's gonna not worry about this stuff. Wait, I feel like we could commit whatever the fuck we did here. I don't remember what we did. I feel like the LOD stuff will be important when we start hitting bottlenecks, but at the moment we're just like so unbottlenecked. We're like it makes it worse, which is just so ironic to me, because I was going to go, oh, we could do like a LOD, it'd be like apparently just rip the whole LOD out, it's just faster. It's so fucking dumb. Because the only way that the LOD wouldn't be faster would literally be to drop the quantity of LOD done. Like we would have to somehow do something with the LOD to make it worth doing it faster. Like it could make an impact if our shader was too slow, because we can speed the shader up and that kind of thing, but we're also apparently like not discarding stuff when it's low opacity. I don't know if it needs that, but I do that so that like if you have part of a block that was opaque or something like that. Alright. I don't know what this did, so first off, we'll go here and we'll go untick everything, tick this and say add average to FPS. Okay, so add average to FPS, and then do this and say add solid as LOD level. Okay, cool. So do that and push that. I'm trying to think what can I do to like effectively optimize this even better. I feel like the LED stuff is going to be important. I just don't know what scale the world has to get to for the LED stuff to mean anything. like in theory, we could also do something like if you're completely surrounded by solid, you could turn yourself off. Because, like, okay, that's what we're doing. That's what we're doing. All right, we're going to pivot to perpetually centering the player. So, to do that, we need to go, hey, chunk. So, map chunk. We have, like, a data type called, like, a chunk ID. So like, map here. Chunk ID. Right? I have a chunk ID, maybe, somewhere. The fuck is my chunk ID? No. You can tell I've done this too much because I'm going, I have a chunk ID somewhere. It's like, no, I do. Yeah, there's chunk ID. So chunk ID is apparently inside chunk. So the player needs a chunk ID. So we have a new chunk ID, which is just an ID. And then we can go up then from translation, which is just that flawed in it. Yeah, but again, like what I'm struggling with here in terms of the scale of everything is will the LOD stuff be important if we don't also reduce the data quantity? Like definitely the LOD stuff I could see it speeding up if we were also reducing the texture size and everything that we were passing to LOD, because that would result in like basically saying that once you get beyond a certain distance, we're just going to store like a solid color for an entire chunk so that we can render really far away chunks. But everything else just makes me go, like as soon as it can't batch them, we lose the value, which means that we result in effectively there being no reason. You know what I mean? Like if there is actually no optimization, like if the batching is just always going to be beneficial over doing LOD stuff, even if we make the 1 to 16 scale, it's still really far away. Like you may as well still render everything, because at that point then like other colorings come in and all that kind of stuff. I don't know. It baffles me because it's so much faster. I would have thought the LOD stuff would have at least had some trade-off. So yeah, maybe it's like once we start getting to millions of chunks instead of millions of voxels. I don't know. It's so confusing. Anyway, move the world. I'll put a Futurama reference here, not the ship. Anyway, it's a Futurama reference. So this is going to take in player. Hello. Actually, I feel like maybe there should be an observer on trigger on move up on move. So we have move world, and we're going to say move. So we need a struct and enum struct. No, we'll give it a struct because it'll be easy. Move world and IVEC 3. Then this is derived event. Right. What the fuck? Brain? No, it's a new type, so let's do that. Okay. So we have move world, and then we're going to say we need mute player, because we need the single player, because we need to actually physically move them. We're also going to need the technical player's offset. I think it's going to be good. The current 1 kilometer view distance in Minecraft terms becomes just 64 meter view, so 4 chunk distance in Minecraft terms. Yeah, but that's what I'm saying. Like you're scaling it by 16, but what I'm saying is that like the LOD I don't think kicks in, because if you're scaling it by 16, will the LOD actually matter, or are we better off just making the map 16 times bigger and leaving the like what I'm saying is I don't know if there is a critical size. I guess it's like the O notation of like, if the LOD is like log n, then the fucking normal way of scaling is just n. Like, do we ever get to a world size that we can render so big that the difference between n and log n matters, or will other bottlenecks slow us down that is not actually worth optimizing it because you'll never get to a world that big that you actually run out of GPU? But also, I'm on a pretty good GPU, so maybe it's like on my computer it's fine, but the LOD might become really, really important if you don't have enough video RAM to cache the entire world. Like the LOD, no, that wouldn't matter because we still have to send that. Maybe if we made the LOD not take full resolution textures, like if it took in only the lowered voxel count, that would also make a difference. Oh, I just turned my volume up already. It's weird. Yeah, so basically if we're only taking in a lowered resolution, then it would mean that we could theoretically load a larger world, because beyond a certain distance you don't need to load it all into the GPU, which means we can have a smaller resolution world. But without something like that, I feel like it's kind of wasting our time doing it, because it literally is faster not to do it rendering wise, and I don't know if it'll ever overtake, if that makes sense. Yeah, but that's what I mean, is like technically the way the LOD works is it'd be the bottleneck first, but the LOD, I'm just tweaking my headphones so that my microphone sounds about the right volume in my head. I don't know if it's affecting the stream's volume of my microphone, but it shouldn't. Anyway, so what I'm saying is, I don't know if the level, like whether the memory footprint will become a limitation before the modification we make does anything, because we're actually not lowering the memory footprint, we're actually increasing it, because we have to load the multiple LOD meshes onto the GPU as well. Whereas at the moment, we're loading a full resolution image regardless of the LOD, we're just sampling the image differently. Whereas if we were lowering the resolution of the image as well, which actually shouldn't be that hard to do, because all it means is, as long as it's not too expensive to compute the image, we could recalculate the image when it transitions from one LOD to the other, and basically sample every other pixel and send a half resolution map. But we need to know that we did that so that we can update the LOD, which I guess is a way of doing it. Anyway, so we need to ship the universe and ship. So I guess technically what I'm going to do is this, and then the player's going to keep getting stuck, because the idea is I'm not going to move the world at first to make sure that the player isn't like having a jitter when they teleport, which can be really annoying, because if the world's not moving as well, it's not going to be able to tell if you get a jitter. Anyway, so what we're going to do is we're going to say, hey, trigger, let offset equal move. Well, I guess it's trigger dot offset like this, and then we're going to go here. We're going to here. I guess technically we should just make this a chunk ID. No. So we're going to say event. We're going to say your deref, and we're going to go impl move world, and then we say fm. I guess we'll keep it small. So offset like this. Wait, no, you're not an IVEC. You're just a vec, and then it's itself. Dot 0 times by chunk size as right. So that should then wait, that's fun. As I32. And then you wrap this thing and then you say as vec32, because technically it's faster to compute I32s than vec32s. Anyway, this is our offset, and then we're going to say player.translation minus equals offset. Okay. Something. Use. Minus equals, thank you. So we're going to go here. We're going to say, hey, I'm going to keep this as our own thing, because it's going to be slightly easier to keep track of like what's new. So I'm going to say like app dot add observer move the universe, not the ship, So then the player can keep moving around like the player does. I'm going to say pub detect chunk transition. So I'm going to say that who fucking knows. So this is going to have chunk ID last. What the fuck? Mute commands. Alright, I'm gonna get rid of this because the AI has no idea what it's doing, so it's written fucking complete gibberish here. Okay, so we have the single player. The player is also going to need a mute chunk ID. Wrap this. So we have this, we go, hey, last was here. I guess technically we don't even need last, but the player holds that. So we're just gonna do this. We're just gonna say, hey, so if player dot one dot no, so we say like let pause equals player is a chunk ID from translation, right? That is the chunk ID. Then we're gonna say if pause does not equal 1, does not equal chunk. Technically, we want the player to be able to leave more than just the first chunk, but it's fine. For now, we're going to go with chunk. If I can spell, apparently. Chunk ID 0. Then, player dot 1 plus equals pause. And also we need commands. Apparently I got rid of that. Yeah, we have commands. And we say commands dot trigger move world pause. Negative pause? Negative pause. I think it's negative pause. So we have to do a bunch of things to chunk ID to make it fucking useful. Don't screenshot the fuck. Okay. Anyway, deref mute, debug, clone, copy, par equal. We have to import, add for chunk ID, it's asset and self like this, and then sub is also this. And we can also import sub apparently. Alright. Apparently, so we can say that player's position equals pos dot 1 plus this, so pos dot 1, just because I can't be bothered doing that add a sign. We have to go to chunk ID. Look, neck just cracked like crazy. We go const pub const 0, which is this, which is that, this, and then say, hey, you're saying, hey, you can't do that because you're not immutable. So you're gonna say first off, let's just do 1, thank you. And then I believe it's you'll dereference this and it did dereference that, which is disgusting. And then we say, hey, like this. Hey, okay. Fuck you. Wait, why have I made you public? I don't need to make you public. There. So we detect chunk transition, and we say, hey, add systems. This is going to run, I guess, first, or it could run last. Detect chunk transitions. kind of wanted to run first, but maybe actually last probably makes slightly more sense. The idea being that if the player moves from one chunk, ooh, no, maybe not. Depends when the fucking GPU runs. The first, actually, no, yeah. So we're gonna, yeah, no, yeah. We're gonna go first. The idea being that we don't want the GPU potentially running after last. Like if it's the last thing that happens is we render the world, we want to make sure we move the player. The first thing we do after a frame's been rendered is move the player back to the center. So the idea is I shouldn't actually be able to get out of this chunk. Now, apparently I can get out of this chunk. But why can I get out of this chunk? Why can I get out of this chunk? Did I not save? No, I saved. Why can I not? Okay, detect. Can we print line? Print line. Player moved to chunk. I need to know what the player's current offset is about moving the corresponding chunk offsets around. Right, question. Okay. So apparently you're just like not detecting me leaving a chunk. But I am like leaving a chunk. Where's this player? Am I missing? Oh, that's what I'm missing. The player doesn't have a chunk ID on them. So I'm looking for the chunk ID. So player entity, I'm going to say like require chunk ID. Bam. Fuck you. Default. Oh, wait, no, we have to import default, don't we? Import. Default's its own thing. Default. Also, can we use self 0 just so, yeah, if in future. So that should work, that should work. Whoop, don't run it in run. Ugh, release mode, please. Okay, so doing this should then mean that the player can't leave the starting chunk. Where the fuck are we? Well, that's interesting. Apparently it like moved the world very, very far away. It seems to have slammed me into the ground. So that's fun. Can we just like maybe ignore the Y? Sure. Why is it doing that though? Where does it teleport me? Because it's sending me real fucking far. Like really fucking far. Where the fuck is it teleporting me? That feels like a in the billion, right? Like 1,000. No, it's only 133 million. I wonder if that happens to be 64th of a maximum representable U size. I'm trying to think why it would be doing that. Player. The only thing I can think is that like when I hit it, it's like teleporting me the wrong direction. And instead of teleporting me back into the chunk, it teleports me away from the chunk. So like when we went negative, we want to go positive. Maybe. Hey, look at that. Player move to chunk plus. Right. Annoyingly. Need to be able to get out of the fucking ground. So, god damn it. Fine. We're just gonna say we're stuck in the ground, and then we're gonna go tweak it so that it actually fucking moves the rest of the chunks too. So, effectively, all we need to do is do a little shuffle of the fucking chunky chunks. So we need to go like chunks. and we just go query. Okay, so we need the fucking chunk ID, maybe? I don't know if chunks have chunk ID. We need the chunk. We need the transform, because we need to update its offset. We need it mesh material 3D custom material. So well, no, it's like the idea would be that we can make the map go three-dimensionally. Like it can go up and down indefinitely. The issue is that specifically in the way that the world is set up at the moment, I'm spawning underground and it keeps teleporting me back underground. So I can never look at the map. So I'm going, maybe if I just turned off the Y direction just so I could look and see if it's doing away with it. But I'm going, but that kind of defeats the whole point of making it universal if I'm specifically turning off a direction because it annoys me. So the chunk data, and you have a handle to the chunk data, but I feel like specifically the chunk data should probably also hold the handle to the image. Like this. And just be like an option handle image. Because not only that lets us actually have the LOD stuff stored on the chunk fucking data as well. So then the chunk just becomes a fucking pointer to the image like this. And then we go, hey, chunk data, hey, yeah, so when I generate you, I could actually give it access to the asset server and it could store the fucking image itself. And that's just like hilariously like, of course. So empty, yep, cool. In theory, the image should be the chunk data. Like the fact that I'm converting between the two is maybe not the most advantageous thing. Can I just give you an asset server? Because I'm pretty sure the asset server is fucking Arc. We can just give you an asset server if you don't mind. And then we can just go down here and say, hey, so image is asset server dot add fucking you, so, and then we just say data dot image equals some image, and then just return data, and then we just come up here and say, hey, you just return self, please. This is not necessarily the smartest idea because, you know, we're not actually keeping track of anything. Anyway, so then we go down here. So now you have a copy of your image stored on your image data. And the primary reason for doing that is I just want to be able to copy it across to the chunk. But like hilariously, it's starting to become more and more that the material itself should be the chunk. Anyway, task. Let task spawn to generate. This function takes 3 arguments. Okay, so you are going to take in the asset server. And then you're just going to say asset server define. Like this. You just get an own copy of the asset server, please. Right, and then you insert the task, and now this task, when you insert this task, this task is just chunk data. Whoop, no, correct it there. It's just chunk data because technically the image is now stashed into the asset server and like left alone. So then you just return this, which should in theory make everything so much fucking easier. Because so we add that to the fucking thing. Okay. So again, we get back to this issue of having to put the chunk after. But in theory, we can say data dot image image dot clone. I need to make it public, so I'm just going to clone it now and then go back to here and go, hey, chunk data. Okay. Right. So, yeah, some image. Okay. So I'm going to say maybe something like if Okay, if data dot image is none. Okay, sure, we'll just say that. Well done, right? No, then it's like let that some image equals data image clone, else continue. Then you pass in the image. Wait, don't add asset server. Do you take an option? No, you just take a handle. That's right, you have to take a handle because otherwise you just crash. Image, then I need to clone it. Then we pass that in, and we pass that in, and we say, hey, task here. Why is your task wrong? Because you're saying your task is chunk data. Right, we need to modify the other task set. You also are just chunk data. Yeah, but so technically, because the material holds the data, the material technically has to be updated in that we have to repoint it to the correct data. I'm just finding it kind of funny. That like I'm probably gonna end up making the existence of the chunk the thing that dictates the asset. So how to explain? So first off, does the world still render? It should. So at the moment, the chunk holds the LOD and are pointed to the asset. Some query is querying something, cannot access transform mutably and immutably at the same time. The answer is fuck you. That's in player because you, and so we're accessing your transforms without your transforms. We're not actually going to move these, which means we just need to say without player entity. Basically, it's just saying we're trying to access the player's transform mutably to move the player, but we want to access the chunk transforms immutably at the same time. So you're a reference to that, and then we need to say assets, materials. So the idea is that none of the chunks are changing. And this is what I mean, is technically we're going to have two places that need updating, and that's not a good way of doing it. Anyway. Mute. Res mute. Assets. Custom material. Because the other thing is we don't need to update the position or anything. Like this code is terribly written. So we're going to say for chunk. Okay. So for ID offset. I actually don't think we need to care about the offset, to be honest. But anyway, I'm going to keep it for now. Material. Because we're actually updating the chunk, it's the underlying chunk itself, which is fun. So we can do this. Maybe, I don't know. Something feels slightly off. I'm trying to think this through because, like, we probably need to make up some kind of mapping system so that we can pull out the fucking correct update. You suck. So we have this. So you hold the data. You hold the image. You have the LED, you have the data. The data has the image. I'm trying to remember how to do this. There's a fucking thing you have to do, because you have to make sure you do it in the right order. We have to update all the chunks, then we have to go through and update all the fucking materials. But the idea is that if we change the chunk, I think we need to have like a map struct. I'm just gonna make that because we need to be able to like query like where the chunk's being moved from. So we have like a pub struct chunk lookup. Chunk lookup. Right. And this is just gonna have a fucking hash map, and then not even a chunk. You don't even have a chunk. You have a fucking entity. Right. What the shit's behind my chair. Goddamn. Alright. So we have this, and then we're gonna go do a resource for one thing. Derive resource. Right. Right. So we get this, we do this, and we go right. So I feel like I'm doing this in a terrible way. Where the fuck is my chunk ID? Must be in chunk. Okay, chunk ID. We're gonna import chunk ID. We're gonna say up but on insert. Which takes in a mute world deferred world and context ctx context. Right. So on insert is this. Fuck. We can't put that on the player if we're going to do this because the player will keep eating into the map. I guess we can. It's just we're starting to get dumb, and I'm just doing this because I need to get this working so that I can then try and optimize. There's no point trying to optimize if we haven't got it working. Right. So we're gonna say component on add or on insert. Right. So first off, if deferred world and scope. So if world.get ctx dot entity dot is sum return. So what you need to do is say play entity. This is really bad. I'm gonna put it to do because this is so bad. To do remove this. The player is being explicitly ignored so they don't eat the map. Right. So we return. Then we're going to say let ID equal world.get chunk ID unwrap. Right. And then we're going to say world.get resource mute chunk lookup dot add. I guess it's insert, isn't it? Insert. Right, then we have to go to you chunk lookup and go import chunk lookup. Insert. Okay, so this inserts a specific chunk technically it should be a chunk ID. Because if we ever decide that we change how chunks work, we kind of just want to pass in the chunk ID. Apparently chunk ID is not like hash, I'm guessing. Yeah, not hash. Okay. Just pass into things. Right. So on insert, you do this. Let me say on remove, you do the same thing, and you say remove. And then we're going to say on remove, do that. Context here is the hook context, so it tells you the entity that the component's being added to, the component ID, which is like a per run unique identifier. So it's like not like a type ID where it has to be universally unique, where it's always unique kind of thing. It's just unique to like this world, which means that I think it does things like a resource and a component can have the same component ID, which is even more confusing considering that resources have component IDs. But it means that like technically, if you use a component as a resource, it gets a different ID than if you're using it as a anyway, and then maybe caller or maybe location is like a compiler based optimization thing of like, if you turn on this feature, then it will tell you who spawned this entity, or like who inserted or who removed, like, you know, it'll tell you like the source code line. But if this feature's turned off, it gets compiled out completely. And then relationship hook mode, I have no idea. I haven't looked into that. But it's just, the context is just like information that Bevy passes to a hook when it fires, so that you can like do the right thing, I guess. I think the hook, from what I remember of relationships, the relationship one is going to be like whether you should despawn yourself, like whether you, the relation information, run if not linked, skip. Relationship hook information. Relationship insert replace hooks will always run. Relationship insert replace hooks will run if spawned linked is false, and relationship insert hooks will never will always be skipped. I don't know. So it's saying like in a parent-child relationship, what happens? Like what should you do? Like I guess so that it can work out like, is it a child? Is it a parent? Without actually having to look into it, it can go like, hey, if this is never run, then I know I'm not. Anyway. So on insert and on remove. Weird thing about this is because of how Bevy does its component shift stuff, we can actually just like shuffle them all down. Which is a little bit strange. All right, then we have to go back to player and we go, hey, when we move the world, we need to access the lookup, which is going to be a res chunk lookup. We need to also quickly, before I forget to do it, go back here and make sure we actually insert the fucking app.init resource. These need to be renamed because they don't actually at all describe what they're doing. I mean, the chunk lookup does, but like the mesh generator doesn't at no point generates any meshes. It generates chunks, which is not how it works. Anyway, you need to be default, please, so that you can be just randomly spawned in. All right. So then we go back to player. So what happens is when we spawn a chunk in, we add it to the lookup, and then when we move, we can move things around in the lookup, which I think might break the world if it's generating while we move, but in theory it should just like fix the world fine. We should use this instead. At the moment we're storing the entity when we spawn in a chunk, but we should actually use the chunk ID when we get it to look it up. Anyway, so we are going to need the chunk ID. Of the chunk and the chunk and the chunk material. Okay, so I'm going to call it data and offset. I don't actually think we need the offset, but anyway, we need to look up the next, I guess. So we'll call it like let next equal look up. It's going to be like let sum. Because I haven't actually added it yet, so I can write the API as I go. Let sum next equals lookup dot get and then ID. Else I don't know. one chunk will be empty. And then I guess we're just going to continue. But in theory, like we could despawn these chunks because what we're saying, and we never would because it like infinite world or something. Continue. But the idea being that this is looking up a chunk and then saying, hey, where you're trying to move this chunk is not going to exist. So I guess technically we wouldn't want to despawn this one because we don't actually know if something else is going to move into its place. I don't know how that would look. Anyway. Get, and then let's just get cloned. Right. So next returns an entity. What do you mean? Expected one of the... What do you... So let sum next equals lookup get else. Continue. Right. So I think what we're going to do is let okay. Actually, I don't necessarily want you to continue. Anyway, okay. Maybe we need maybe commands as well. This is feeling like this is I've not thought this through enough. I'm just fucking sticking shit as it goes. So we're gonna say let mute mat equals material dot get mute data dot data. Else material will be empty. Else error material missing. So this is the current chunk. So we're saying this chunk so we get the entity I'm trying to fucking work out how this works in my head, but I don't think so I think I want to look this up. I want to say let so let okay other equals chunks dot get next, right? And then it would be so we don't care about the other one's ID and we don't care about its chunk dot, no, we know we want its data. Ugh. Wait, this would be itself. Are you looking up yourself? No. This is ID plus offset. No, plus move world. Trigger. This. Give me. It's the fuck. How many times did it? Okay. Let next equal dereference ID plus trigger dereference. Right, so we have to go say that a chunk ID can add like this. Right, so then we have the next, and then we say, hey, get next. Right, so we're grabbing the next chunk. Right. So we're gonna say, I guess, error, no next. Right. So we say, hey, some let some get next. Okay. Then we say let the other equal next. So the chunk data, we don't care about the ID because we've already got that as next. The offset, I'm going to say we don't care about. And the material, I also don't think we care about. Like, maybe it's the chunk that we don't care about. So it's like something like this. And we say, hey, else error. I'm just like literally going to try and get this to work. So failed to get chunk. Continue. Everything's going to continue. So we get the material of the other chunk, and then we say, hey, can you say material dot get material dot 0 dot ID. That's the material. So we need to say let chunk equal. So we need to go like mat chunks chunk data is res assets. I'm like talking into my phone. It's fucking stupid. Chunk data. Right. So we have our chunk data. Can't find chunk data in scope. Okay. Into chunk data. Right. So we say let chunk equal chunk data dot get else error chunk data missing. I'm writing error everywhere, but I'm not actually going to crash because I'm 90% sure this isn't going to work on every chunk because I'm not like doing wrapping on the edges and stuff like that. So it's just going to result in me being able to like walk to the edge of a map and just cause it to crash. So it's going to be data dot ID. Right. So now we have our chunk data, and then we've grabbed the material of the other chunk mutably, and then we're going to say mat dot data equals chunk dot image dot unwrap dot clone. I'm going to say if let some image and then we can image a clone. Okay. So apparently we don't need to speak it. I don't know if I've got this correct. But and then it would be we would need entity as well. Oh, wait, no, we have the entity. Entity's next. So then we say commands dot entity next dot insert data. Right. Yeah. I can't dereference it because apparently chunk. But chunk only has a handle in this, which means that chunk can also be cloned. Which means I guess instead of dereference, we're just going to say clone. I want it to be like an explicit thing so you don't accidentally fucking copy chunks around. But like they're just pointers, which means that they should be lightweight. Okay. So to run through the logic of what we're doing here is we're saying the next chunk, where this chunk is going, is the ID plus the trigger position. So basically we say -1, then so the next one is -1 from where we are. Oh, there's my alarm saying the stream's coming to the end in 10 minutes. Whoop, turn that off. Right. So we work out where we're going next. We then get that by looking it up to get the entity. We then access the material of that next chunk. We grab the chunk data from the current chunk, right? Data. We then go to the material. We actually get the material, not just the material point. We grab the material out. We get mutual access to the material, and then if the current chunk has an image loaded, like so, basically the chunk is finished generating. We set the materials data equal to the image, which should then mean that basically we go to where we're going next, and we overwrite the material with the new material, and then we call commands entity next insert data, and we probably also want to insert ourselves. Now, my concern here is I want to be able to call remove on everything, and calling remove on everything is when we've done. But we need to pump data in, and we also pump in ID and like dereference ID. Right. So then what we do is we say, hey, that entity that we just changed the data of, we want to insert ourself and our ID onto it. So basically, we go override it with our ID. And then that should work because it means that the material doesn't change, the mesh doesn't change. We just updated the pointer and then updated the other pointer. Now, what is throwing an error? Something's throwing an error because I apparently imported E from an unstable library feature. Even my computer's in on fucking making sure that the stream ends on time. My computer's crashed like fucking crazy, which means that we're probably doing some weird pointer shit. But yeah, that took down my computer. So what I kind of want to do is actually maybe just turn off the actual moving of the player, and hopefully, because it's like, I think what happened is that we eventually moved outside of the thing entirely. But what I need to do is say, like, don't fucking move the player so that I can just see if the world is actually moving how I think it should be moving. Yeah. For fuck's sake, doing this again. Rust, stop. Rust downloads, please fuck off. What the fuck is going on? Back in the lounge. So just everything is fucking going crazy. Can you please stop offsetting the player? And then we're gonna go to our terminal. We're gonna run. We're gonna just see if we can if the world is moving how we think it was moving, because it was kind of funny. Kept teleporting back because it took 2 or 3 movements before the fucking crashed. Which again, I don't think this has anything to do with Bevy or Rust. I'm pretty sure it's just like one of my RAM chips is fucked, and my computer only tries to use it if I use too much RAM. And it was just like when it moved around, it just tried to move the RAM to a certain location, and it didn't like that. I mean, it could be an async issue, but like I doubt it. Oh god, it's so slow. It really shouldn't have been fucking debug writing shit, I guess. It's so great. Fuck. Well, I think we moved the world, just not the fucking right spot. Fuck me. It's so slow. The fuck is it doing? It's just console and fucking. Okay, so apparently we like moved a whole bunch of chunks like outside of the world. I'm just gonna turn off all these debug error messages. I just want to see if it fucking worked. It's not just that it's just a couple of errors, it's that it's the same error multiple times, and also because of the just sheer fucking like lag spike that it caused. I think when all the chunks generate, as you'll notice, we appear to not be updating it correctly in that we've cloned that chunk all the way. See, that's what's happening. Is I moved out of the spawning chunk, and then it effectively just clone stamped that chunk indefinitely. So if I go up, it'll just clone stamp the chunk up because it never moves me back. Alright, what I'm going to do is instead of fucking re-offsetting the player, I'm literally just going to say that the player's translation equals vec30. Because doing that will mean that, like, what's happening at the moment is I think I'm teleporting myself in, like, the wrong direction or something. That means that when I leave a chunk, it doesn't reset me right so that I end up back inside the chunk. Or it, like, overcorrects and shoots me out the other side of the chunk, which is then causing it to, like, clone stamp the fucking world the whole way. So, as soon as I pop out the top of this chunk, everything moved somewhere. Apparently down, which is not the direction of... am I just stuck under the ground then? Is that what's going on? I guess. I guess we need more negative chunks. Okay. Let's do that. Let's go to the world gen, because we've got like 3 minutes left before I'm going to call the stream. We're going to go when we spawn the world, please give me like negative like 10 chunks. We're just gonna like lower the world down because we really don't need it to be so negative 16, negative 16, negative 16. Like we've dunked on Minecraft enough to show that like we don't need the fucking world to be so massive. Right, so apparently I need to go down, which ironically means that the code is working correctly and that when I go down it teleports the whole world below me, but I think that's actually the wrong direction in that when I go down right, it doesn't update the meshes, does it? So what's happening here is that we're teleporting the meshes under the... Well, that's an easy fix, because we can literally just go wherever it was that we spawned in. Oh, right, a whole bunch of them never... Okay. So we need to also say, hey, so instead of your offset, like your transform and offset, I don't want to update the mesh. So what we should probably do is move the universe, not the ship. It's supposed to be ship, not shit, but anyway. So first off, we learned we don't need the transform. Second off, we learned we don't need the transform. I think what we're going to do is, because technically speaking, it's faster anyway, we're going to go turn off the piece of code that like matches, and so now we just need to do the hidden tweak, because like technically the air is still broken, so like we're hiding the air, which means if it goes from a chunk that was completely visible to a chunk that had anything visible to a chunk that, so we could, in theory, because we can see ourselves here, data.chunk, we're going to say if data dot LOD hint equals empty, we can say visibility hidden else visibility visible. What the fuck? No, let v equal. All right, so it's like visibility hidden, otherwise it's visibility visible, and then we just also insert that when we move. Right, the idea being that like basically we already know that a chunk is empty. Like it's apparently not in a root, you know, or super or whatever. Just LOD map LOD empty. So now I'm doing it in release, not release mode. Release mode, please. So what I can conclude is that like this code is terribly put together because I was just trying to rushing to get it done in half an hour. But theoretically, now it should also bring the visibility statement status, which means when I go down, I mean, like, I believe what is happening here is we are not actually clearing up chunks, so that's why the mountaintops stay they never get overwritten, which means that they get to live forever. So we overwrite the material status with itself, correct? Okay, which means that what we could in theory do is say maybe clear out for underscore no material, right? Don't despawn every fucking, let material equal continue. Don't increase the materials. It's so close to being smart, but also incredibly fucking stupid. We need access to map gen. I don't know where the map gen is, but it's also, it's like it's mesh gen, but anyway. Mesh generator. Thank you. Can you? Apparently that's probably private, to be honest. Mesh generator. You're private, aren't you? Yep. Can I make it public, please? Okay, this is what I mean. Like, none of this stuff is named correctly because it was supposed to be the mesh generator, then it became the chunk generator, and now it's doing other shit. Anyway, we need you, and I need to say like that everything Everything is the dummy data, please. I'm just gonna say dummy image as like that's how we call it, and then we're gonna go back to you. I really want to get this working. So no, it never will, because technically it's not the mesh generator, it's the chunk generator, and that's why it'll never make sense. it never ever like generates a mesh. It was from the beginning and will probably forever always be intended to be apparently I made this method fucking private. It was intended to be the thing that's in charge of its, so it should actually be called the chunk manager is what it should be called, because it's in charge of making sure that the chunks generate in the right order and in the right place and like keep track of each other and that kind of thing. But I call it the mesh generator, I guess, because I was doing something with mesh when I first named it, and it's in my head. I went, oh yeah, mesh generator. It's like, no, it's not a mesh generator, it's a chunk generator. Anyway, that many chunks. Okay, it's going up, going down. Okay, so those other ones are a bit weird, but I think that's because they're, you know, it is kind of eating the map like that. Anyway, eat the map. That's fun. So if I go down, here we go. I mean, it kind of works. My question is, I don't remember if my piece of code works that like resets or like why those ones are broken. My suspicion is that they're still generating when I go to move, and because I moved while they're still generating, they're getting overwritten with the new generated data, because we don't keep track of the ID when we generate them. We keep track of the specific entity we're overwriting. But like, as you can see, like it works in that when I fly down and I leave the chunk, except why? Why did I move 3 times? Why did you call this fucking function 3 fucking times? Why does it get to call it more than once? Anyway, it apparently triggers 3 fucking times. Why? Why do you trigger it 3 fucking times? Player. We say, hey, app, observer, move the universe, not the ship as an observer. And then we detect the player in one fucking system that runs on first. We take the player's fucking position. Oh, it's probably because I'm teleporting to 0, and 0 is not the center of a chunk. If the player says that, we say, hey, move the fucking thing here. And we say, hey, can you tell me to teleport me to like flat 16, like half the chunk size, just like, you know, just fucking punt me up. Yeah, it's well, it's not just that it's globally offset, it's literally like when we do the chunk generation, not the map generation, chunk generation, when I call the mesh generator, the update mesh generator, right? When I say, hey, queue this task, the task here, I think it must be inside the mesh generator. Where the fuck is it? Mesh generator. In here. The mapping is between entity and task. But if the chunks move, right? Oh, look, it works if I wait. Oh, wow. It's almost like if I wait for the world to finish generating. Yeah, so what's happening is that effectively, I don't trust the chunks. I feel like that I feel like is happening because here, like I moved negative and I moved positive, I moved negative. I think if it triggers twice, it's possible that like it doesn't get moved properly. That, or for some reason, those chunks are over here. that's also like a distinct possibility. It is slowly eating the world, and for no reason, because like all it is the data is eventually getting stamped over the top. So my code is ramshackle stuck together is why it's breaking. It's not actually. Oh, I love it. That lag spike is also horrendous. So potentially iterating through every single fucking chunk is probably not the best idea. But yeah, something is overriding data that it shouldn't be overriding, but that's it. Like, in theory, it should be really like easy to do like a instead of like this is where you have to start profiling things, because like what I can do is split this up and say, hey, don't do this here. Do this like here, and say fn actually no, it'd be do it in fucking in map and be like fn hide empty chunks, and then you say, hey, query chunk mute visibility, and you say changed chunk, right? And then we go, hey, for chunk visibility in chunks like this, we intermit you. I don't know why it grabbed commands. I think the AI is having a bit of a fit that like I keep having commands at the end, and usually and then we say, hey, if chunk LOD hint equals LOD empty visibility hidden otherwise visible, and then we can say, hey, run this like in I don't know. I want to say it's like app.add system pre-update. I don't actually know when it extracts shit into the render world to be rendered, because the idea is that you just need the visibility to happen before then, so that it doesn't like render a frame and then not render a frame. So we just need to hide empty chunks, and then we do that on its own, which means that like in theory it like should take way less time, because it's actually like moving things around less, because we're just actually changing the visibility. We're not fucking fighting the visibility. It still takes ages, but yeah, but it makes a lot of sense. It's more just like I'm doing really dumb shit here, because what part of what I think's happening there, like what's making things be eaten by the void is somewhere. And again, I'm supposed to be ending the stream about 10 minutes over where I was going to end. I just want to like explain things, because like you're really good at the math, and so you might be able to fix a lot of this stuff while I'm not streaming, because it's like you'll make sense if I can explain it to you beyond the Bevy weirdness. So what I'm doing is some really, really bad stuff in here, which is I'm taking all this stuff and using basically like this resource, the chunk lookup, is like the state now, and then I'm moving everything into the new location, but like it's like a sort of a double copied thing where I'm taking the chunk now and setting its material later, which also, weirdly enough, they don't actually need to be the same query, which would probably make it even faster, because you could like just and they don't even need the fucking transforms. They don't need the filter either. We just say, hey, chunk ID and chunk, and then we say material mats for material, and then we say, hey hey now you can say material in chunks and in material, and then what mats. So you need to iterate through the materials. You can also do this like this because it looks nicer. No, it's because it's mesh material to the custom material, like this. Right. So we go, hey, so iterate through this, clear all those, which should slightly be faster, I think, because it's not querying this extra information, it's not grabbing it. Then we don't have to grab this information because we don't actually need it. And then again, we can like not grab this information. because it's like mats. But what's causing the bug that like is making things get eaten is that I'm inserting the new data over the old data, which means that depending on when the observers fire for updating and tracking like on, add, on, insert, and on, remove logic, something is overwriting what chunk something's going to, and eventually they always get overwritten to zeros because like once it's gone out of the world, I'm not actually tracking it properly. I'm just sort of, at the moment, because of this implementation, I'm just literally moving pointers around and hoping that no data erases happen that erase my pointer before I get to use it. Yeah, this definitely needs to be fixed. I'll fix that off stream though. The same as like this big massive lag spike shouldn't really be happening either. Also, as noted before, I'm teleporting the fucking player back into the center of the chunk, which is kind of fun, to be honest. Yeah, unnecessary. Anyway, I'm gonna call the stream done. Otherwise, I will end up streaming for 5 more hours. So I'm gonna go have lunch. Thank you for tuning in. I will hopefully be streaming tomorrow and working on this, and I'll probably work on it this afternoon because I'm actually like super excited to try and fix this piece of logic without having to try and make it interesting to talk about and actually like reason through what the fuck everything's doing. Honestly, what might end up happening is we'll just like I'll probably store like a second copy of what like this is what the world looked like, and then this is what the world looked like after. So when the player transitions from chunk to chunk, it's like suddenly like the issue is I need to make it so much faster because it's so slow. The other option is don't do any of this bullshit because we're no longer doing the LOD stuff and literally just spawn, despawn, and that like chunks that are far away. And then we could have like an invisible ring of chunks. So when you play, okay, I'll do that. That seems like a much smarter idea. Anyway, thank you for tuning into the stream. I will see you next stream when I will hopefully have this working. Now I've got to work out how to close the stream. Yeah. An idle room we can have, and yeah.